start recording. Remember, those of us who will present the paper and the presentation, we will be submitted for the indexing in all the databases we are eager to be our papers to be submitted to. Well, the first presenter, I'm not sure I can see the proper the presenter, but I will call and then we shall discuss if there's anyone from the first team. It's the Alina Shafronenko, Yevgeny Vodyansky, Diana Rudenko, Anton Polubechin, and Dmitro Frolov. Am I right? Is there anyone of the presenters? If so, let me know. If not, well, I see the Maria Shirokopetlieva. Maria, maybe if no one will from the first team, if no one will submit for the presentation, Maria, will you be able to present, to be the first presenter?
Sorry, our works will be presented by Alexander Dolgonenko.
Yes, okay. I can present.
You can. Okay, I just another minute. The first presenters: the Alina Shafronenko, Yevgeny Budyansky, Diana Rudenko, Anton Polubechin, and Dmitro Frolov. Well, if our colleagues will join us, it's only 3 minutes started, but still, I would like to stick to the timetable. And okay, Alexander, be so kind to present. As soon as the colleagues will appear, we will change the queue and they will present. Alexander, please take the floor. And now we are going to listen to the research of methods for image sharpness evaluation in photos of people. Am I right, Alexander?
Yes, that is correct.
Okay, so probably you are able to share the screen. Can you check it?
Of course, yes.
Oh, we do. We can see it. Very nice. So take the floor.
Okay, so once again, my name is Alexander Dolgonenko. And as mentioned, I'll be presenting our research on the topic of image sharpness evaluation in photos of people. So the idea for this research, it originated from like a very practical problem, which frankly, every professional photographer faces. And that is, after a photo session, they need to sort and filter thousands of photos based on things like composition, lighting, but like most commonly, image sharpness. And this is like the defining quality of a photo. And automating this step would significantly simplify the workflow. So the research field is image sharpness evaluation, but what exactly is image sharpness? Well, we can say that it is a very relative value that cannot be standardized because of multiple factors, and it defines the level of detail of a given photo. And camera settings such as shutter speed, ISO, and aperture, all of them influence the resulting image sharpness in one way or another. So please have a look at this example. The first image is considered sharp. Image number 2 has motion blur. Image number 3 is soft due to grain. And image number 4 has the subject outside the depth of field, which results in overall blurriness. So in short, depth of field determines the depth of the photo environment that will be in critical focus and is the direct product of the lens aperture, which can be set manually. If we want to evaluate the sharpness of an image, we can use basic mathematical approaches to do so. For example, with the fast Fourier transform, we can analyze the spatial domain of the image. And with Laplace dispersion approach, we can iterate over image blocks and detect edge contrasts. However, it turns out that in the purest form, these algorithms are not effective enough for photos of people. And there's also this small experiment, we can see that there's a direct negative correlation of sharpness to background quantity. So the more background the photo has, the less sharp it will be considered by these algorithms. Therefore, we can state that since professionals evaluate portrait image sharpness based on the subjects, when processing the entire image without taking into account the quantities and type of the background, we will always result in very inaccurate sharpness evaluation results. So the goal of this research is to propose an improved algorithm that would allow classifying the level of sharpness of a given set of photos that would be accurate enough regardless of the background quantities and composition. So purely based on the sharpness of faces that had to be in critical focus at the time the photo was taken. We will then compare the results with the previously mentioned algorithms. So we started with identifying the steps of the improved algorithm, like the top level steps. And these are finding all faces in the frame, performing calculations to determine which of these faces should be evaluated for sharpness and which should be ignored, and then processing and proceeding to calculate the sharpness and present the result. In order to calculate the distance to the subjects in the frame and calculate the quote-unquote ideal depth of field, we heavily rely on metadata analysis. And metadata is conveniently packaged within most modern image file formats. So we save the crucial fields like focal length, aperture, and circle of confusion, but we also use the baked-in face coordinates if the camera produces them. And of course, the facial coordinates in the metadata are not that common, so we incorporated a backup solution that uses cascade classifiers to locate the faces on the image. And that can be easily achieved with something like an OpenCV library. Now, given we have retrieved the sensor size from the metadata and estimated the subject size, we can calculate the distance to that subject using the base rule of optics. The main calculation effort of the algorithm is determining which faces had to be in critical focus. We could, of course, just use the metadata aperture and base our calculations on that. However, we understand that the aperture value may have been set manually and may not have been ideal for the photo seen. So instead, we use the exposure value and maximum acceptable ISO value to determine the quote-unquote ideal depth of field, which is presented in Formula 2. We then get the boundaries of that depth of field using the formula number 3. And having the depth of field boundaries and having calculated the distances to the faces, we can easily determine which of them have to be evaluated for sharpness and which should be ignored. To use the data from our calculations, we designed a modular architecture that implements the improved algorithm. And this will allow easily modifying and expanding the domain of our algorithm in the future. And for our prototype, we use technologies like Kotlin, Bash, and OpenCV. And on the slide, you can see a debugging snapshot result of the algorithm marking the selected faces, distance to them, and their estimated sharpness. The files then get marked from green to red based on their relative sharpness. We then evaluated the accuracy of the improved algorithm compared to the base FFT and Laplace methods. We can see that the estimated accuracy is significantly higher with our approach. But keep in mind, under the hood, the improved algorithm still uses the base FFT or Laplace, depending on the configuration. But the accuracy is much higher because the processed image area is significantly decreased. We also evaluated the performance of the methods, and we can see that despite our algorithm having more steps, it still outperforms the base FFT and Laplace because the processed image area is significantly reduced. So as a result, by analyzing the metadata, gathering information about the photo, like how it was taken, under which conditions, we can then mathematically estimate and predict which faces on the image most likely have been intended to be in focus. We then use the base FFT or Laplace methods to evaluate the sharpness of these faces, which produces a reliable sharpness estimation and does it much quicker than traditional methods. In the future, we can further expand the domain of this algorithm by supporting photos of animals or landscape photography, but this comes with its own challenges. And for now, thank you very much for your attention, and I will gladly answer any questions.
Thank you, Alexander, for the presentation. Yeah, if there are any questions, then please. Yeah, Alexander, I was going to ask about this landscape, the landscape question, but you already give me a reply that it might be in the future or it has some difficulties. But well, I do like your presentation so much.
Thank you very much.
Can you please, well, I will ask, can you go back to the picture, the last one with the results? Yeah, this one. No. Where the photography is? Yeah. There is a number, a black number above the green screens on the picture. Is this the distance, this black number?
Yes, this is the distance in meters, the estimated distance to our subjects based on some parameters we get from the camera.
Okay, so it's in meters, so it's about 10 centimeters difference. I see. Okay, thanks a lot. Yeah, I suspected it to be so. Thanks a lot, Alexander. Maybe more questions for our presenter. He is the first one today. Well, if there are any questions, you can contact the conference organizers and they will pass the question to Alexander, or we have a chat. And for now, thanks a lot for your presentation.
Thank you very much.
So much, Alexander. If the first team of the first presenters, I will check some of the people who are in our room, and if I find those who haven't presented yet, then I will give the floor to them first. But for now, I believe I see Yevhen Vasyl. Is
Good morning.
Okay, will you be able to present now? I do understand it's a little bit before schedule, but still, will you be able?
I think we can start.
Yes, thanks a lot. Okay, now is Yevhen's presentation on fast color image cluster for real-time computer vision and AI systems.
Okay.
Yes,
So,
we can see the full screen. Yeah, thanks a lot.
Yeah, cool. So I think we can start. My name is Yevhen Vasyl, and today I'm glad to present our study, fast color images clustering for real-time computer vision and artificial intelligence systems. Let's get into it. The development of innovative tools and modern technologies for pattern recognition is increasingly focused on the utilization of new models and algorithms of artificial intelligence, including clustering, artificial networks, and classification. However, challenges persist in achieving computational efficiency, particularly when applied in embedded systems. And traditional clustering algorithms face challenges in constructing clusters of arbitrary shape, leading to computational bottlenecks in modern computer vision systems. To solve this problem, in this work we propose a fast algorithm for constructing clusters of arbitrary shape. The parameterization of the algorithm makes it possible to effectively adapt it both in powerful server system and less powerful embedded system. Unless otherwise stated, the input data is a colored image in RGB format. Let's now explore some common algorithms in practice. Partitioning algorithms, methods like k-means and k-medoids partition data based on proximity. Hierarchical. This approach builds cluster hierarchies through a merging or splitting the data points. And density-based. Algorithm identity clusters based on dense regions in data space. This type of algorithm offers diverse strategies for clustering, each with its own set of strengths and limitations. In our study, we delved into analysis of color density within the RGB color model. And in our methodology, we employ image downsampling technique to reduce computational complexity while retaining essential image features. Downsampling involves reducing the resolution of the image by subsampling or averaging neighboring pixels. This process allows for faster processing times and reduced memory requirements without significant loss of information. We optimize partitioning grid of the RGBA space to reduce clustering complexity. Image preprocessing involves scanning and forming a matrix to capture color distribution across pixels. Clustering is then performed using this matrix. By dividing the RGB space into an enlarged itself and aggregating frequencies, we achieve computational efficiency. Further analysis of frequency distribution aids in constructing cluster of arbitrary shape. This visualization allows us to observe how the enlarged cells in the RGB space partition contribute to reducing computational complexity while maintaining crucial image features. In many images, the dominant objects have significantly higher color frequencies than other objects, appearing as distinct pixels on histograms. Analyzing all frequency distribution lines is unnecessary. So to address this, we quantize frequencies into a predetermined number of levels, balancing computational complexity and quality. A non-linear quantization law is used to mitigate the influence of dominant objects. We propose flexible boundaries for frequency quantization levels. After determined model parameters, image preprocessing follows these steps. At first step, we resize the image, and second step, we scan the image when we find cell frequencies on an enlarged grid in RGB space. Then we quantize frequencies and use these frequencies with quantization level instead of frequencies. Wavelet methods offer a powerful approach to cluster formation, leveraging the concept of wavelets to analyze image data. This method proceeds through the following steps. At first step, we upon that is shown into a new level, all cells are traversed, starting with a higher density. New cluster forms if the centroid doesn't belong to any exact cluster and no cluster formation is ongoing. Next step, second step, new cluster forms with the cell becoming its head. Neymorin cells in a space 3 to 3 to 3 cells analyzed. All adjustment cells on the same layer are added to the cluster. And final step, cluster formation continues until none of the infused data cells in it have any free neighboring cell located on the same level. Then, after we scanning all cells, collision detection occurs between newly formed cluster and those on the layer above. If a cluster on the current layer collides with one on the layer above, this cluster match. And additionally, if two clusters share a neighbor on the previous layer, they match into 1, 2. And here are the outcomes of our algorithm. We will now present an image showcasing the effectiveness and accuracy of our color clustering method. Let's take a look at the algorithm's performance and evaluate its efficiency. Our findings are summarized in this table. It outlines the size of cell, number of colors detected, processing time in seconds, and the clustering efficiency shift. In result, we have introduced fast clustering algorithm designed for images in RGB color space. By employing preprocessing and adaptive quantization, we have effectively reduced computational complexity and enabling fast clustering. Algorithm effectiveness allows for its utilization in low-power embedded system with parameters adjustable to specific tests, but also proficient in candid monochromatic elements. Algorithm may face challenges with diffuse color. So that's all. Thanks for attention.
Thank you, Johan, for the presentation. And maybe there are some questions from the audience. If no questions, Johan, will it be so difficult? Maybe you considered changing the image from RGB to any other format? Is it?
It's we trying to use different type of format, but prefer to use RGB, and you can use it as a start any different format, but better to transfer it to RGB before you start to use this algorithm, and it's not a big problem.
Okay, I see. Because, well, your algorithm fits better for this RGB. Okay, thanks a lot, Ivan, for the presentation. Thanks for the reply. Maybe there are some more questions for our presenter. Well, thanks, Ivan. If are any questions, contact me in the chat or contact us in the chat. I will pass all the questions to those who were presenting. Thanks, Ivan, for the presentation. Again, I see first presenter. What about the Olga Cherednichenko, Natalia Sharonova, Hanna Plechova, and Nadia Bobkova? Do we have any of the team already with us? No, but I see Dmitro Chernyshev. Dmitro, am I right? Can you, well, you're supposed to present with Olga Cherednichenko, Dmitro Sitnikov, and Polina Sitnikova, but as nobody else yet from the previous teams is with us, or you maybe be presented for both presentations, no?
No, I have only this one.
Yeah, very good. So would you be so kind to take the floor, and we will wait for the next presenters whenever they will be able to start.
Okay, sure.
Presentation. Okay.
Thank you.
As you see, we are going in quite a bit of time ahead the schedule, but it's okay. We have all the presenters we need. And I see there's a Yulia Sheika. I do remember you haven't had the possibility to present yesterday. Will you be able if?
Yes, sure.
Okay,
I'm ready.
You're ready? Okay.
Thank you.
So,
Thank you.
Dmitro, please take the floor.
Yes. Greetings, everyone. Thank you for giving me the opportunity to present our latest research, which focuses on a novel approach for evaluating machine learning models. In the rapidly evolving field of machine learning, the effectiveness of a model is often gauged by its predictive accuracy. However, this singular metric doesn't always provide a comprehensive view of a model's performance or its interaction with the underlying data. Our research is about generalizing machine learning evaluation through the integration of Shannon entropy and offset theory. Shannon entropy is a key measure in information theory, quantifies the uncertainty or information content within a system. On the other hand, offset theory offers a framework for dealing with vagueness and granularity in data, providing insights into its intrinsic structure. By combining these two theories, we aim to offer a more nuanced and holistic evaluation of machine learning models. This methodology doesn't just focus on how well a model predicts, but also sheds light on the underlying data complexity and how the model interacts with it. We believe this integrated approach can significantly enhance our ability to assess, compare, and improve machine learning models, ultimately leading to more robust and interpretable AI systems. I'm excited to delve into the details of our research and share with you our findings and their implications for the future of machine learning evaluation. Let's get started. So let's start delving into In this approach, that integration entropy and rough set theory, this integration isn't just a technical novelty, it's a significant shift in how we assess machine learning models, moving beyond more accuracy to understand the deeper interplay of data features and model behavior. Why is this integration significant? Machine learning isn't just about making accurate predictions. It's about understanding those predictions in the context of the data inherent complexity and the model's interaction with the data. This approach not only enhances the interpretability of models, but also sheds light on the underlying data complexity, guiding to better decision-making and model selection. So what do we do exactly? We combine the uncertainty measure provided by Shannon entropy with the granularity insights from rough set theory. This unique integration allows us to examine machine learning models from a fresh perspective. Here's how it works in practice. We start by breaking down our dataset into smaller, more manageable subsets using rough set theory. This is what we call data granulation. Then we apply Shannon entropy to these subsets to quantify the amount of information or uncertainty they hold. This step is crucial as it sheds light on the informational content within each granule, highlighting how different data attributes interact and contribute to the overall structure. So our experiments were meticulously structured to assess the effectiveness and applicability of this novel approach across different datasets and machine learning models. We selected two distinct datasets for our experiments: the Titanic dataset and a fundamental dataset in machine learning known for its binary classification tasks of predicting passenger survival, and the Microsoft malware detection dataset, which is far more complex and high-dimensional, used to distinguish between benign and malicious software. This selection was intentional to showcase the versatility and robustness of our methodology across different data complexities. As we dive to the next slide, we will focus on the results and insights gained from our experiments, and we uncover some compelling findings about how data granularity influences the performance of various machine learning models. By integrating Shannon entropy and rough set theory, we've crafted a unique vantage point to observe this impact. Let's consider the key highlights. Our investigation reveals that decision tree model performance notably improves as we increase data granularity, signaling its sensitivity to data volume. On the other hand, the random forest model demonstrates a gradual enhancement in performance, showcasing its inherent robustness and lower susceptibility to overfitting compared to the decision tree. When we turn our attention to logistic regression, we observe a fascinating pattern. The model shows a relatively stable performance at lower data volumes, but doesn't significantly benefit from an increase in data granularity. This suggests that there is a threshold in data volume beyond which logistic regression doesn't gain additional performance boost. Now let's spotlight the key nearest neighbor model. It stands out by showing a significant improvement in performance with increased data granularity. This underscores KNN reliance on data volume, aligning with the intuitive understanding that more data can provide a better context for its instance-based learning approach. To visually encapsulate this insight, we've included a graph depicting the trend of entropy changes over granularity for both Titanic and malware detection datasets. In essence, these results don't just quantify performance, they illuminate the intricate dance between the data granularity and model behavior, offering a nuanced perspective that extends beyond traditional evaluation metrics. As we conclude our exploration into the innovative integration of Shannon entropy and rough set theory for machine learning model evaluation, let's reflect on the pivotal contributions and envision the promising avenues this research opens. Our journey into this research has revealed a groundbreaking approach that not only quantifies model. Yeah. You want something to add? Sorry. Our journey into this research has revealed a groundbreaking approach that not only quantifies model performance, but also sheds light on the intricate dance between data complexity and algorithmic behavior. The implications of this research are profound. Our experiments across diverse datasets have underscored the versatility and depth of insights this method provides. But what excites us most is the road ahead. Imagine the possibilities as we extend this methodology to a broader spectrum of machine learning models and model selection algorithms. Or, yeah, delving deeper into complex data realms and refining our algorithms with an enriched palette of evaluation criteria. Thank you for your attention, and now I will be glad to answer some questions. Thank you.
Thank you, Dmitro, for the presentation. Alexander, I see you got a question, please.
Yeah, Dmitry, first of all, very interesting topic. I have a question, maybe I missed it in the slide, but how does this approach affect the speed of machine learning?
Yeah, so of course it affects the machine learning model drastically, because it's some sort of it can be compared to ensembles. So yeah, it's mostly like ensembles in terms of computation complexity. So we need to sample different machine learning models in order to produce such graphs. Yeah.
Understood. Thank you.
Thank you. Okay, thanks, Alexander, for the question, and Dmitro for the reply. Maybe more questions from the audience. Okay, well, if no questions, again, you can ask me in the chat and I will pass the question to the presenter. Thanks, Dmitro, for the presentation. According to what I see in our in people who have joined the now the conference, this workshop, I might ask some of us who are supposed to present much later. I see here is the Mamata Das. Will you be able to present the paper now? And yeah, maybe Dmitro, you would like to stop sharing the screen, or I will. Okay, I will help you with stopping sharing the screen. Okay, I see that here is the Mamata Das. Maybe you will be able to present. If not, maybe Tetiana Neskorodeva. I do understand that you are much later supposed to present the paper, but maybe you will be able to do this now, if it's okay with you.
Ma'am, I need
Yeah.
I need 5 minutes, because I thought I'm in second panel. Maybe my number is later. That's why.
Okay.
Next I will present, ma'am. After one I will present, ma'am.
Okay.
Yes,
So maybe thanks a lot. I do understand it's such a short notice, but okay. Maybe Yulia Sheika, will you be able to give the presentation, if it's okay? Yes.
Yes, sure.
Thanks a lot. You saved the day.
Thank you for giving the floor. Just a second, I'm sharing the screen. Share, just a second. Yeah, and full screen, please. Yeah, thank you. So, dear colleagues, let me introduce our topic, that is quantitative characteristics of the author's EDA style.
But I'm sorry, Yulia, but we don't see the full screen. Are we intent to see the full screen?
Yeah, because I have it on my screen, the full. Well, maybe I won't share for the full screen. Is it okay to have like that?
I do. Yes. We have.
Oh,
now we see the second.
Yeah,
page.
thank you,
Okay.
because it was moving somehow. I didn't.
Okay.
Thank you. Sorry. So, linguistic is one of the first humanitarian sciences that uses mathematical modeling and computer information approaches to analyze data and conduct research. So, to objectify and optimize linguistic research, creating text corpora is an effective method that can also provide new perspective for traditional concepts. So initially, only any collection of text used for linguistic studies was considered a corpus. However, with the introduction of the first electronic text corpus in the 1960s, a more precise definition appeared. So a language corpus is now defined as a collection of oral or written language data in electronic form. So in contemporary linguistic, corpus-based studies have become a significant area of research. And various scholars have proposed classification of linguistic corpora based on several factors. So these factors may include the type of linguistic data, whether corpus consists of written or oral or mixed text, whether it's multi-purpose or specialized, whether the corpus is available, that is, it's free, commercial, or closed, and many, many others. Residenska-Kulczycka argues that corpora could be identified as full text, fragmentary, explanatory, illustrative, and others. The types you can see on slide, so let me not to read that. So also linguistic corpora are characterized by four main parameters. So first, the corpus size should be significant enough to be representative of the subject or field. Secondly, it should be structured and tagged for efficient use. Thirdly, the text included in the corpus must be digitized for ease of access and analysis. Fourthly, the concept of electronic corpus includes special software for working with corpus. These parameters are essential to ensure the corpus quality and effectiveness in linguistic analysis. So in corpus linguistics, users interact with the corpus through specialized software tools or corpus managers, which offer diverse means to extract the necessary information from corpus. So these tools enable users to conduct various types of research, and additionally, users can access information on the origin or type of the text, as well as obtain lexical, grammatical, statistical data, and users may also save selected concordance lines in a separate line, in a separate file on their computer. So linguistic experts have identified several key criteria for standard corpora, including sufficiency, consistency, reproducibility, correctness, feasibility of data collection, technological ability, and clarity. So therefore, the following marking system that you can see on the slide has been used in our research corpus. So in terms of typological and applicative characteristics, the corpus of Vasyly's prose can be classified as illustrative because it has been compiled for the purpose of linguistic statistical analysis of the writer's dialect. Also, it's full text because it contains the complete text of the author. It is static because it doesn't allow any further addition of the text. It's also language corpus because only texts by Vasyl were included, and of course it's monolingual because it has text only in Ukrainian language, and it's written, so the corpus is a collection of written texts, and annotated textual data are tagged as at the syntactic level. So the following software has been used to establish the quantitative and qualitative characteristics of the corpus. First of all, it was sounds, particularly the word forms option. Then it was Ancon toolkit and its wordless option, and programs coded in Python by authors to work with the corpus. By meeting all the requirements for creating a linguistic corpus, we have obtained a conventional tool that can be used for work of any complexity, especially for solving the specific objectives of our research. So the story in a collage and 42 short stories by Vasyl has been selected for the study. General quantity characteristics of the corpus you can see on the slide. And texts of the research corpus were first digitalized, then they were normalized and tagged. The Ancon program has been used to generate a list of word forms from the story in a clutch and short stories. So this list was subsequently transferred to Microsoft Excel for lemmatization, reducing word forms to their dictionary form. So thus, as a result of the analysis of the corpus, we obtained the following results that are presented in table on a slide. So a linguistic statistical analysis of the research corpus of text by Vasyl has been conducted following the established methodology developed by Solomia Buk, Igor Kuczycki, and Larisa Tioch. The main characteristics of the text were identified, and they are the following. So that was the volume of the text, the number of word forms, the vocabulary volume, and others. So additionally, the ratio for speech in a given text can serve as a statistical parameter of an individual author's style and a characteristic feature of a particular work. The research corpus has been subjected to morphological tagging using the classical division of words into part of speech, and the frequency of each part of speech in the text has been automatically obtained as shown in a table that you can see on the slide. So besides several other coefficients have been calculating using the formula that you can see in our full paper. And these coefficients have been calculated to quantitatively characterize the lexical level of Vasyl's works of fiction in various ways. So these richness of vocabulary, text exclusivity, and others, and the results you can see on the slide. So to sum up, the creation of a linguistic corpus requires careful selection of text based on different aspects. The corpus of Vasyl's prose serves as a valuable source of studying the author's idiom style, offering both quantitative and qualitative analysis of language. Quantitative characteristics of the research corpus, such as word uses, word forms, part of speech, have been analyzed for the story in a clutch and 42 short stories by Vasyl. Digitalization, normalization, tagging, and analysis using software tools like Kong and Microsoft Excel have been facilitated data processing and statistical analysis. Overall, linguistic corpora and their analysis offer valuable resources and methodologies for studying language, enabling the researchers to gain a deep understanding of linguistic phenomena, language variation, and idiolects. These corpora provide a solid foundation for empirical research and facilitate the development of linguistic theories and concepts. So thank you for your attention. If you have any questions, please do not hesitate to ask or contact other co-authors. Thank you.
Thanks a lot, Julia, for the presentation. Yeah, maybe, yes, I do understand that we are in the machine learning workshop, but still, maybe you do have some questions, colleagues. Maybe there will be some questions and I will either reply or send it to you so you could answer them. Thanks a lot, Julia, for the presentation. Thank you so much. Thanks for helping us.
Thank you. Please stop my presentation. Stop sharing my presentation. Thank
you. Okay. And
yeah, thank you very much.
Thanks a lot, Julia. Okay. Well, maybe the Das, will you be able to present the paper now? How do you feel?
Yes, ma'am. Sure, ma'am. Sure.
Thanks a lot.
Yes. Okay. Just a second. I'm sharing my screen, ma'am.
Yes.
I think my presentation is available right now.
Yeah, we can see it.
It is visible, right, ma'am?
Yes, it is.
So hello, everyone. Hello, respected ma'am. This is Mamta Das from NIT Trichy, a PhD scholar from India. And I'm working my research in the field of bioinformatics with machine learning. And today I will discuss the prediction of subcellular localization of E. coli bacteria using machine learning classifier. So now this is my table of content. And let's get started with the significance of the protein subcellular localization. Like, what is protein subcellular localization, or PSL? So this is basically the prediction where the protein reside in a cell. And it is a multi-class classification problem where a protein sequence is assigned to 1 or 4 to 16 compartment. Here we can see the general structure of the cell with a defined compartment, right? So here we determine the environment in which the protein operate. They control how proteins work by deciding who can interact with them. So in our study, we have taken the E. coli bacteria. Here we can see the general structure of E. coli bacteria with the defined compartments here, right? So now why we choose this E. coli bacteria in our research work? The some reasons is like this E. coli is the bacteria that commonly lies in the lower intestine of one-blooded organism, like including human and the animal. And in fact, this E. coli are the part of our normal bacteria flora. Like most of the E. coli strain have the beneficial functions. Like for example, they may prevent the establishment of harmful bacteria in our intestine. So, however, there are some pathogenic bacteria. We can see here the VTEC and STEC. This is nothing but two different kind of pathogenic E. coli bacteria. And here, some of among these pathogenic E. coli bacteria, there are one group of E. coli strain that are capable of producing toxin. And this group of strain is known as the verocytotoxin producing E. coli, that is VTEC. And another one is the Siga toxin producing E. coli, better we know is STEC. So now the infection in human with VTEC leads to mild bloody diarrhea. Like however, also more severe complication can occur, which may potentially even lead the kidney failure also. So the consumption of the contaminated food or contaminated water, or it also may contract with the infection by some infected animals or close to control contact with the infected human also. So now this VTEC is found in the vegetables and some dairy product made from the raw milk. Now, what can we do in order to protect this, protect to ourselves from these pathogens? We can. It is advised that the refrigerate the foods, or it is also advised to wash hand, and also vegetables and fruits we can wash in the time of the cutting. We can wash the cutting board and the knives also to preparing at the time of food. So based on this, the advantage and disadvantage, E. coli bacteria, I choose it is in my data set. So these are the some related work in our work. I have mentioned only 5 in my paper. We have mentioned so many. So here we have a recent 5 papers we have included with us as per the guidelines. So here we can see in the recent one paper, Arora et al. Have used some machine learning methods to predict the protein subcellular localization, and they have used some data set like EPIS or DB, and Musli et al. Also used some MSLP data set, also predict the protein subcellular localization with some machine learning algorithm. And other two also, they have used some different data set and predict the subcellular localization with some different compartment of the cell. And in our work, we have chosen the E. coli bacteria with this machine learning algorithm, 7 algorithm, and some compartments. So here I have mentioned the data set features, like we have chosen the total 9 compartments like cytoplasm, inner membrane without signal sequence. This all are I have included here. And total we have 336 instances with 7 features. Here we can see the 7 features I have mentioned, and the short form here I have mentioned short form, full form I have mentioned here. So these are my features with 7 features and 336 36 instances, and it is taken from the UCI machine learning repository. Now this I already mentioned this machine learning method we have chosen, and for the performance parameter we choose the accuracy, precision, recall, and F1 score, because we are classifying the like which protein sequence is under which compartment. That is, it is a multi-class classification problem. So for this reason we have chosen accuracy, precision, recall, and this F score, so we can get the harmonic balance of this precision and recall. So here we have mentioned the TP, TN, FP, and FN. This all are the usual meaning we know. Now these are the performance result, and this from this table we can see that the linear this LDA get the precision of high and recall and if one was score. But in case of SVM, we got the highest accuracy, that is 0.871569, which is near to the LDA. All are the machine learning algorithm all do the bit good, but in from them SVM got the highest accuracy and LDA. So now from this we can see in this figure, we can visually we can see, yes, this LD and the SVM got the highest result as per like it should be like that. And here in this figure we can see the execution time of all the machine learning algorithm, and we can also check the yes, here we can see this LSVM, that's a linear support vector machine, got the highest taking highest execution time to execute this program, and minimum time is taken by LDA, KNN, CART, NB, and the LSVM. These are the confusion metrics we got from all the machine learning algorithm. Excuse me. And now these are the future direction we are planning to include the stacking or boosting, or we are planning also to take some other different data set. Maybe this time we took the E. coli bacteria, next time maybe we can choose the human or some other viruses. And we are also planning to include some Markov clustering technique or TF-IDF technique. And maybe next time we will consider some other compartments are present in the cell, because in this bacteria we know only 5 to 6 compartment is there, but when we will choose the human and some other high graded protein, maybe that time we will get the extra compartment like 16 or 20 like that. So these are our future directions, and these are the references we have used in these presentations. So these are the short presentation from my side. Thank you, ma'am.
Thank you so much, Mamatadas. Thank you so much. And I will those. Oh, hi, so nice to see you. Maybe there are some questions for the presenter.
Yes, ma'am.
If there are questions. Maybe I shall start. The data you were saying, maybe I missed this information. Is it an open data, or you find it somewhere? Is it your own data, the one you were used?
No, ma'am, this is open data we got from machine learning repository, but from there we choose some features. Which feature is for multi-classification problem, which feature is very important to find out the compartment, like which sequences belongs to which compartment. For this reason we choose 7 features. The data set is available. From this we have to find out the good features, ma'am.
I see. Thanks a lot. Yeah. I thought so, but I just missed this exactly text. Thanks a lot. Well, more questions if there are any. Well, you are always welcome to ask me in the chat, and I will give the question to whom it's supposed to be asked. Thanks a lot. Thank you for the presentation. So nice to see you.
Thank you, ma'am.
Yeah, hope to
Yes,
see you at the next conferences as well.
Yes, of course, ma'am.
Thanks a lot. So see you for now. I do see that we have the presenter, the Nadia Babkova, with the intelligent methods of secure routing in software-defined networks. Nadia, will you be able to start the presentation? Yes, you are. Okay.
Yes, hello,
Hello.
everyone. Nice to see you.
Yes.
And I try to start.
Yeah, we can see the full screen.
Okay. So hello, everyone. Hello, dear colleague. Nice to present our topic, intelligent method of secure routing in software-defined network. So what does it mean, software network, and why we need to know some information about it? In intelligence, sorry. An intelligent system is one of the type of automated information system that are based on knowledge and the essay of research in intelligent software system and organized knowledge base become relevant, especially decision support system in various fields, including network security. This our work is dedicated to relevant scientific problem related to analysis of threats, attack target, and improvement of potential solution for enhancing level of network security in the data plane of SDN and network through the use to intelligent routing method. The purpose of work is to research and improvement of exciting method of use routing in software-defined network using intelligent support tools. So a number of security routing models have been developed and investigate, taking into account base vulnerability critical metric. An exciting model has been refined, leading to formulation of an optimized base flow model for security QoS routing. And you could see this structure on figure of this slide. Numerical analysis has demonstrated the eventually and adequacy of proposed refinement. Therefore, network function visualization consists of three main components, like VNF, virtual network function, are network function implemented in software that can be deployed with the NFVI. That means network function virtualization infrastructure. So NFVI common hardware and software component where they are deployed visualizate a network function, and the last one is management and orchestration environment. So security threats related to SDN infrastructure are classified based on affected level as follow: application management, data layer, and application management interface, and the last management interface. From rubric of intelligent third and fourth level draw maximum attention, as knowledge base can be created by shaping this knowledge from system text message. Widen the scope of this work, typical security problem and attack object, widen the data plane, network device controlled by SDN controller, analyze. So the result of this analysis are presented in table. Clearly, device at the various network level can be object of attack, and according to well-defined multi-level architecture of SDN, security threats can be classified at different levels. So the base group of metric represents interval vulnerability characteristic that remain constant over time and across user. It consists of three sets of indicators. The first is exploitability. This indicator reflects the technical means by which a vulnerability is exploited. This set has four indicators, like attack vector, attack complexity, required privileges, and user interaction. The second set is impact. This indicator includes degree of impact on core security goal, confidently, integrity, and availability. And the last one is scope. This indicator is part of the base metric group, although it's somewhat independent of the rest of group. Despite the numerous security challenges in cloud computer, Cloud Security Alliance has identified 12 critical security threats related to nature of shared dimension cloud computing that have the greatest impact of compare business, and all of them you could see on this slide. With the growing interest in software-defined networking and widespread deployment of software-defined networking, their vulnerability in combating security threats gradually became apparent. Security question are closely related to characteristic in SDN. According to research, the following aspect makes software-defined network vulnerable to attack. Widen the SDN architecture separate level are implemented for control plane and data plane, unlike a traditional network where these planes operate in a single device. The control plane follows flow rules, while the data plane is responsible only for forwarding data packets according to the flow rules. So, for example, the lexical used in such system, which is fundamental for creating knowledge base in intelligent system, is provided on this table. This stage is necessary for forming a system of features to create logical equation. The specified, indicated, and base metric characterize the overall complexity of implementing an attack using an particular vulnerability of the node of network. For example, we try to, in fact, we try to use some predicate algebra to take information, to have information from our SDN system. So we propose an approach based on finite predicate algebra and method of comparison. The general form of such problem is built on base of predicate equation, and we have two set of variables, the features and the features that you see, and exactly describe variable, and we try to use both of this set like properties and features, and think that it can be related to each other in the form of complex logical dependence, which can be represented as predicate equation that we have in number 1 of this slide, where P is a finite predicate. So classifying the considered object means determine based on this predicate equation and experimental data about this our features, which properties this object has and which properties it doesn't correspond to. When based on the priority dependency and experimental data of the features, it's possible to determine to which class the given object belong. As evident from the above consideration, the values of features are grouped into a matrix. Suppose that is the result of the experiment, we obtain some data related to values of features, describe the classify object, and complete the following predicate equation, describe the relationship between them. And the task of object classification can be formalized as solving the following predication equation by finding the unknown predicate f. In research related to logical interface in knowledge base, question areas about the tightness of relationship between the features of this object, as well as a question about this significant or insignificant. It has been proven that the formal relationship between features is stronger than a few set of values of this variable satisfy the equation. A comparative analysis for exciting model of security routing, a QS routing model with a metric analogous of the OSPF protocol, and an improved model of security QS routing taking into account base vulnerability critical metric has been conducted, and the study provides the efficacy and efficiency of this proposed model. The flexibility to use intelligent method for security routing. And the last is our conclusion. So to achieve these goals, standards for building software-defined network we analyze, and it's note that SDN is modern approach to design, building, and operating information and communicate network by separating management and data forwarding plane This distribution provides network with direct programmability and dynamic as well as abstraction of functional capability from infrastructure layer. Network function visualization has become a standardized way to development, implement, and management network service. However, growing interest in SDN and their deployment has relieved their shortcoming in a combination cybersecurity threats. Based on research of typical security problem, it becomes apparent that centralized control and SDN programmability features provide powerful and convention channel for attackers. The analysis of vulnerability in SDN data plane and functional capabilities of routing means to counter possible attack, showing the prospect of using security routing tools based on basic vulnerability critical metric to enhance the network security level of SDN data plane. In turn, the analysis of CVS standard for equential vulnerability assignment of network equipment proved feasibility of its use in development and research of promising approach to security routing field of intelligent data processing in software configured network. So it's a small part of our design, and thank you for your attention. Maybe some question.
Yes, thanks, Nadia, for the presentation. Yeah, maybe there are some questions from our colleagues, those who joined us today. Okay. As maybe no questions, but as we have no questions, neither in an audience or in chat, let me check the chat for a second. Okay, no, but Nadia, no questions. Thanks a lot for the presentation. If more questions, then you are most welcome to write it in the chat, and I will send them to those whom it's supposed to be asked. Thanks, Nadia, for the presentation.
Thanks for all.
Yeah, thanks a lot. I see. I have a message in the chat that Tetiana Skorodyeva would be able to present the presentation. I do understand, Tetiana, that it's much earlier than it's your time. But
I'm ready to present.
Yes, if you be so kind, please let me check. Maybe there is someone else from the no. Yes, if it is okay with you, then we would like to hear your presentation. There's one more person from the first part of our workshop supposed to present. I don't see them yet. Maybe they will appear, and we will definitely listen to the Tetiana's presentation. Then we shall have probably a break if nobody new will appear, and then start another session according to this timetable at 11:30. And those who were not able to present in time, then we will find a time gap for them to present their papers. Tetiana, please take the floor.
Do you see my presentation?
Yeah, full screen. We see. Yeah, we see it properly.
Dear participant, let me present paper, Intellectual Classification Method of Gymnastic Elements based on combination of descriptive and generative approach by authors Alexey Smirnov, Yevgen Fedorov, Anastasia Naskorodyeva, Tetiana Naskorodyeva. Assessing of the performance of elements in rhythmic gymnastics is a complex task. Every element from tones and throwing movement to flexibility and balance is subjected to rigorous analysis. The difficulty lies in the fact that the assessment of such element is subject to subjective interpretation and requires a high level of professionalism from experts. This work discusses classification gymnastic elements shown in dynamics-based analysis sequence frames. In this context, the development of intelligent methods for classifying gymnastic elements by Vasyl can significantly improve the objectivity and effectivity of the evaluation process in rhythmic gymnastics. The first approach to intelligent imagery classification was generative approach, which was based on hidden Markov models. The second approach to intelligent image classification was the descriptive approach, and deep neural network began to be used to increase recognition accuracy, which present on the current slide. Purpose and objectives of the research. But the purpose of the research is to increase the efficiency of intellectual classification of gymnastic elements using a combination descriptive and generative approach. Objectives. The first one creates the structure of the method for the intellectual classification of the gymnastic elements, which combines descriptive and generative approaches. Develop a one-dimensional neural network model for classifying frames of gymnastic elements. Create a model of two-dimensional neural network for classifying frames of the gymnastic elements. Develop a method for identifying the parameters of neural network. Create the method for classifying the sequence of frames of gymnastic elements. Select quality criteria for method and conduct numerical study. Proposed method and model present on the current slide. The structure of the intellectual method classification of gymnastic elements based on combination descriptive and generative approach include a next step. The first one to initially identify the parameter of neural network, manually labeled frames from standard database used, and based on labeled frames of database for future use in the Viterbi method, the following are calculated. Present on the current slide. Next step, second, frames of gymnastic elements are recognized using a neural network. Short step, a modified Viterbi algorithm is used, which optimizes segmentation. Present on current slide. Fourth step, the parameters of neural network model are identified using frame markers of gymnastic elements, obtained using a modified Viterbi algorithm. Fifth step, for a given subject area, frames of gymnastic elements are recognized using a neural network. Six, if the recognition error of the neural network exceeds the threshold, then go to step 3. Next, we consider models of neural network that mark frames of gymnastic elements. Neural network model for classifying frames of gymnastic elements based on multiplier principle present on the current slide. Neural network model for classifying frames of gymnastic elements based on two-dimensional net present on the slide. Let V be position in the connection region, K be number of cell planes in the input layer, K be number of cell planes in the downsampling layers, and other signification. Next slide present this model. Third step, calculate the output signal for down sampling layer. Fourth step, check number of layer. Fifth step, output calculation for a fully connected layer. Sixth step, output calculation for output layer. Next method for classifying a sequence of frames with genetic element based on Viterbi algorithm present on the current slide. This method includes next steps: the first pre-processing, second initialization, third recursion, fourth step end, and 5 restoring the path sequence of state. Quality criteria selection for the method of intellectual classification of genetic elements. In the work to assess the identification of parameters of mathematical model of neural network, the following were selected: accuracy criterion, categorical cross entropy criterion, third performance criterion, experiment. For the experiment, a numerical study was carried out based on the dataset RG-Rotate dataset, which consists of 49 examples of performing a tone in the back split position without using the hands, with the torso horizontal. The dance were collected from the video broadcast of the final stage of the 2020 first Olympic Games in Tokyo. The example consists of elements performed by 8 different gymnasts with 4 types of apparatus. Each example consists of an ordered set of images. The number of images in the example depends on the duration of the athlete performance of element. This structure allows you to store changes in body position when performing a rotation element. 1 second of execution is described by 30 frames. The data set is divided into a training set of 39 examples and test set of 10 examples of element execution. No pre-processing of the dataset was performed. From dataset, 80% of the images were randomly selected for the training set, and 20% of the images were the validation and test set. Due to the fact that deep neural networks do not contain recurrent connection, training was carried out using GPU. To implement the proposed neural network, the TensorFlow package was used. Google was chosen as the software environment Google Colab. The frames of an example execution show the body position when performing a rotation element. Next slide presents the structure model. MLP based neural network model is two-dimensional net-based neural network model. The characteristic is present on the current slide. Result losses dependence based on the categorical entropy on the number of iterations for a model based on a 3-layer MLP present on the current slide. Next slide about accuracy. Accuracy depends on the number of iterations for a model based on a 3-layer MLP. Losses dependence based on categorical entropy or number of iterations for two-dimensional model net. Accuracy depends on the number of iterations for two-dimensional model net. Losses dependence on the number of convolution layer down sampling layer pairs for two-dimensional based model net. discussions. As a result of numerical studies, the following was established. The minimum number of iterations for a neural network model based on a 3-layer MLP in terms of losses and accuracy is 18. Minimum number of iterations for two-dimensional neural network model net in terms of loss and accuracy is 11. The best number of convolution layer down sampling layer pairs for a two-dimensional neural network model net in terms of losses is 2. To prevent overfitting, the scaffold cross entropy method with number of vote of 5 was used. And conclusions. The first, to solve the problem of increasing of the efficiency of classification of gymnastic elements corresponding artificial intelligence method for investigating. The studies have shown that today the most effective is the use of hidden Markov models, generative approach, and neural network descriptive approach. The created method has the following advantages. The input image is not square, which expands to the scope of application. The number of pairs convolution layer down sampling layer is determined empirically, which increases the accuracy of identifying by model. The number of planes is defined as the quotient of number of cells in the input layer divided by 2, the power of 2. The power is equal to twice the number of the power convolution layer down sampling layer. To preserve the total number of cells in the layers after down sampling, which have the size of the layer planes by height and width, which optimize the determination of the structure of the model layer. The use of a neural network allows us to label frames of gymnastic elements, and the use generative approach allows the resulting sequence of labeled frames of gymnastic element analysis efficiently. Further prospects for research are they use the proposed method of intelligent classification for various intelligent visual image recognition system. Thank you for attention.
Yeah, I was dealing with some issues. Thank you, Tetiana, for the presentation. And yes, the colleagues, be so kind to ask any questions you would like to on the performance the Tetiana just made. If there are any questions, discussions. So, well, Tetiana, I really like the subject with the athletes. This idea and this approach. Thanks, very interesting. I liked it a lot. And I do like, and I'm glad that you have such a result and they can be applied in different and various area of image recognition. Thanks a lot for the presentation and in such a short notice. Thanks for being able to present. Thank you so much. And I see we still have, thanks a lot. I see we still have time, and I see there's a Serhiy Zinchenko. I'm not sure, Serhiy, I have found you as the one of the presenters. Am I missing something? Serhiy Zinchenko.
Good day, colleagues.
Hello.
Good day, colleagues. Yeah. One minute.
No, Serhiy, you're supposed to present in this section, right? What was the title of your presentation? Maybe I'm missing something. Just I don't really see it.
I need 2 or 3 minutes.
Okay, but you're supposed to present here in machine learning workshop. Am I right? Maybe you are in a different workshop, because I just don't. What is the title of your
I
presentation?
my present in a different workshop, not in this workshop.
Is this workshop ongoing? Maybe you should join the other workshop, no?
Now I present my work, our work. Okay,
Okay, but what,
in this workshop.
if you insist, but what workshop are you from? So I could contact my colleagues and said that we had Serhiy Zvinchenko with us, so they didn't miss you. In what you're supposed to present today or yesterday?
I present today.
Today, okay. What was the title of your workshop, the one you're supposed to present?
1 minute. 1 minute. Our presentation named automatic prevention of the vessel parametric rolling on the wave.
Yeah, I see it. Okay, your workshop it's ongoing. Why would you like me to share the link with your workshop so you could present in the proper place, because we're a little bit different workshop. Would you like me to send you the link to your workshop, your real workshop? Would you like? Because it's
Якщо можливо, тому що можна я на українській мові запитаю, скажу.
Окей, добре.
Тому що я не зовсім розумію. Наш виступ у іншому воркшопі запланований. Так? Але ви називаєте тут моє ім'я. Я взагалі тут випадково. Просто зайшов, щоб послухати мого колегу Олександра Шарко.
Ага. Добре, тоді добре. Олександр Шарко. Але пана Олександра ще наразі його виступу немає. Він буде після 11:30. Тому, якщо зараз немає доповідачів з нашої секції, нас тоді буде перерва до 11:30, і в 11:30 ми продовжимо з тими, ну, бо з першої секції вже всі виступили, з першої частинки. Тому в 11:30 продовжимо.
Дуже дякую вам за інформацію.
Добре, окей. Так, добре, де ваш воркшоп?
Я виступатиму у своїй секції, то я розумів, да. Ви просто мене побачили, мабуть, серед учасників, і тому захотіли, щоб я виступив у вас.
Так, я мусила знати, чи ви наш студент, кажуть, чи ви наш доповідач, чи не наш. Добре, окей. We understood and get it.
Thank you.
Okay, with Serhiy Zvinchenko, he's just visitor. Well, as much as I see, the first part of our section of our workshop came to the end because all those who supposed to present in the first part till 11 o'clock already did it. So for now, as we have no visitors, nobody from the next parts of the workshop, if there are any questions, I will gladly answer them. If not, that I will start a break and we will come back to the presentation at 11:30 after the coffee break to be able to feed. You can't see it. Okay, to be able to feed the timetable, this official that we have one. Okay, so if there are any questions, raise your hand and let me know, or ask me in the chat. If no questions, then I will say thanks a lot for being here, and I do invite you for the next part of this workshop. It will start at 11:30, the same link. And for now, we will have the break, and this is what I have found a way how to announce to our participants that that we are on a break, as it says. I will add an information on the screen. Just a second. Like this. No, not yet. No. Just a second, just wait, just look at me for another 10 seconds. Like this. Not yet. Okay, well, I will find a way how to inform our colleagues that we will continue at 11:30. For now, thanks a lot. I'm waiting like if I was a beauty page like this content. Thanks a lot for visiting, for participation. I will wait for you back at 11:30 with the new to listen and to work with new presenters, with new people who will give their speeches and their presentations. Yeah, we're on the second half, on the second part of the machine learning workshop of the Collins conference. It's 11:31 already. Our next presenter is supposed to be Victoria Vysotska, Sergey Vladov. I see Sergey Vladov. Oh, Sergey, I see you here. There's your colleague.
Good day.
Slan. Hello, Sergey. Alexei Yurko and Andriy Voronin. As I said, the first presenter, Mamata Das, she already gave the speech. Will you be able?
Yeah. Yes. One second. Так.
Take your time. I do understand it's a little bit too quickly, but.
Do you see my presentation?
Just a second. Yes, we can see it. Yes, we can see it. Can you please move to the next slide?
I make sure.
So we could check it. Can you move to this next slide so we could check whether it's working? Yeah, it's okay. Yeah, please take the floor, be so kind. The title of your presentation is Neurofuzzy Methods for Detecting Sensor Failures in Helicopters Turboshaft Engines. Please.
Thank you. Good day. With your permission, I present a work. Neurofuzzy Methods for Detecting Sensor Failures in Helicopters Turboshaft Engines. The movement control of modern helicopters faces significant uncertainties in parameters, flight modes, and environmental conditions, alongside potential emergency situations such as engine failures and structural damage. To address fault tolerance in helicopter control, two primary aspects must be considered: the reconfiguration of control algorithm during failure situation and the simultaneous identification of failures, accuracy, nature, and source. Sensor failures in helicopters turboshaft engine pose significant challenges as they provide critical information for helicopter movement control. Classical failure detection methods encountering difficulties stemming from nonlinear models, measurements, inaccuracies, and large data volumes, alongside issues of signal-to-noise ratio and computational complexity. Moreover, classical methods often require system model linearization and simplification, which may not align with the task's complexity. Neural network methods, particularly neurofuzzy networks, emerge as promising solution for fault-tolerant control, offering advantages in our common classical methods limitations. Neurofuzzy network demonstrate effectiveness in identification task, highlighting the need for developing the neurofuzzy methods for detecting helicopter turboshaft engine sensor failures. Timely detection of failures can prevent emergencies, while a neural network failure classifier enhances diagnostic accuracy, reduces helicopter downtime, and complements traditional monitoring and diagnostic techniques, enhancing overall efficiency. The computation of helicopter turboshaft engine thermal gas dynamic parameters encompassing air intake in the combustion chamber, specific engine output, and the fuel-to-air consumption ratio within the chamber is accompanied through a neural network model specifically designed for helicopter's turboshaft engine. This model developed by this authors group are presented on this slide. The transition to employing neurofuzzy network signals a promising direction for enhancing the mathematical modeling of helicopter's turboshaft engine, enabling improved efficiency and precision in controlling and monitoring their activities. The Adaptive Neurofuzzy Network Inference System, ANFI, Adaptive Network-Based Fuzzy Inference System is a hybrid multi-layer artificial neural network of a spatial structure without feedback and presented on this slide. The hybrid methods of training the neurofuzzy network and ANFIS was proposed through the use of the ADAM methods or as a gradient-based optimization algorithm, as well as the adaptive k-means clustering methods for optimizing the shape of fuzzy membership function. The following helicopter's turboshaft engine thermogas dynamic parameters recorded on helicopter board are used as input data on this work, reduced to absolute parameters according to the theory of gas dynamic similarity. Gas generator rotor RPM, gas temperature in front of the compressor turbine, free turbine rotor speed, fuel consumption. To train in a neurofuzzy network, we employ a hybrid network training approach which merges the ADAM methods with the modified inverse gradient discrete methods. To train and process encompasses a specific number of circles known as epoch set at 450. The evolution of the model's accuracy is construction a fuzzy inference system related on the root mean square error metric assessed across both training and testing data sets. This slide presents the results of computational experiment, which was a simulation of identifier and determining the location of failure gas temperature sensor in front of the compressor turbine. Since the failure is abrupt and additive and the movement of its occurrence, there is a sharp deviation from the standard behaviors for the gas temperature in front of the compressor turbine. To make the algorithm resistant to false positive caused by modeling errors and noise thresholds and introduced to each neural network model according to expression that takes into account the average value of the performance indicator and the standard deviation. These tables present a comparative evolution of the precision and conventional and neurofuzzy approach in failure classification. They illustrate the likelihoods of first and second type errors in classifying faults, including measuring channel failure in gas temperature processing in compressor turbine, gas generator malfunction, and combustion chamber defects. The data provided in these tables affirm that intelligent techniques exhibit superior efficiency in detecting faults within engine components and subsystems. This table shows the results of calculating the coefficients of erroriness and qualitativity of in the identification of failures and defects. Gas temperature in front of the compressor turbine sensor failure, failure of the free turbine rotor speed measuring channel, gas generator defect, combustion chamber defect. The conclusions are presented on this slide. Thank you for attention.
Thank you so much for the presentation. And now I'd like invite our colleagues and participants to ask questions for the presenter. Let me stop sharing the screen. It will be better. Okay, so those of us who joined the second half, second part of the workshop, are there any questions for the presenter? If there are questions, Sergey, I believe no questions, you know. Well, those of us, well, you can ask the questions in the chat and then I will send it to the presenter and he or she will be able to give a reply. Okay, Sergey, for now, thanks for the presentation.
Thank you.
Thank you so much. Thanks.
Thank you.
Glad you joined us. Glad you participate in the conference. The next paper, maybe Alexander Sharko. I saw somewhere. No, there's an Artem Sharko. Dmitry Stepanchikov, Sir, will be able to present? No, there is an Artem Sharko and Artem Yanenko. So a lot of participants, a lot of authors of the next presentation. Who will take the floor? Either Artem Sharko or...
Hi, I present this work, but I don't know, I mean, is this presentation we must play in video or we must...
No, just share the slides and give your speech. No video,
okay, give a minute.
Okay, maybe if it's difficult, you will need some time. Okay, maybe the next presenter, Georgi.
Yes, okay, thank you.
Okay, I will ask, maybe someone else will present and then we'll go back to you so you will have some time to prepare. Georgi Yaskov, Andriy Chukhai, Yelizaveta Yaskova, and Andriy Zhuravka. I'm not sure I can see any of the presenters in here. Natalia Kusul, Vlada Svich, and Bogdan Potuzhny. No, I'm going to the next part of our workshop. Sergey Khlamov, Vadim Savanevich, Vladimir Vasenko, and Emil Hadziev. No. Sergey Semerikov, Andriy Kupin, Dmitro Zubov, Maxim Kozay, and Vladislav Oliver. No. Alexei Horokhvatsky. No. Natalia Vnukova, Victoria Ostapenko, Victoria Tищенко, Vyacheslav Kovtun, Oksana Kovtun, Bogdan Melnik, Sergis. Okay, and probably those participants, they're supposed to start later, but I do have one presenter, Andrei Marusik. Andrei, will you be so kind to take the floor and give the presentation until we wait for the next presenter?
Yeah, I would be really glad to do that.
Thanks a lot. You are helping and saving the day.
Okay, I must be sharing my presentation, right?
Yeah, we can see the full screen.
Okay, my report was on plastic waste on water surfaces detection, like using convolutional neural networks. And first of all, I want to speak why I chose the CNNs. Of course, in computer vision, there's many different approaches how to do the computer vision, how to detect objects. There are many traditional methods, like for example, developing features by yourself, by hands, like picking and choosing the right kernels and applying these many convolutions by your hands and seeing and comparing which kernels works the best. But nowadays we're not living like in 2015. We have good CNNs, we have pretty fast computation, and we can use actually convolutional neural networks. The key idea of convolutional neural networks is that we extract these features dynamically, then we train our network to extract the right features. And here's some key ideas and approaches that actually were used when doing this work. Like, of course, convolutional networks, pooling queries, activation functions that introduce some non-linearity. Like back in the days, we used some sigmoids, and now we by default use some row. It's actually pretty fast and pretty cool. Fully connected ways, to extract our feature vectors and do actual classification and do this stuff. Backpropagation training, of course, our favorite, gradient descent that nowadays codes better than some people. Also like parameter sharing, that's like going to fine tuning and transfer learning. Yeah, like we use pre-trained models on big data sets of data of images, and we just fine tune and on our specific tasks that actually allows to like use not much data for your specific domain, but still get pretty good results. This actually was one of the key goals of my works, to see how can I apply the state-of-the-art solutions, like just in home at my computer, to like achieve some good results with just a like not very big public data set. And also one key part of this research was that using and utilizing data augmentation, like it's just applying some transformations to the images, like some slide rotation, slide brightness change, stuff like that, some translation, some affine transformations, like, yeah. So then when we don't have much data, we can like make it actually bigger, the bigger amount. So also about advantages of CNNs, actually I like talked some about them just on previous slide. Yeah, of course it's like hierarchical feature learning, so that when we're doing the CNN, it's first we learns about some like just pretty small parts, some strokes, yes, some lines, and when it goes down the line, like down the CNN, we can extract bigger and bigger features like from lines like straights to some objects, to some cats or faces, or whatever. It's what we're doing. Bottles, for example, of this work. And about the data set, it was just a public data set. It's called Kill Plastic in Rivers. They collected this data in Indonesia, I believe. They just have a drone that flied over the above the rivers and the shores and just collected all of this plastic waste. We can see it's not normalized at all. It's like plastic bottles have many more annotations than everything else. And it's actually gonna affect, yes, sadly gonna affect the performance, the accuracy of the network for the all cases. But with utilizing of data augmentation, we still actually can achieve pretty good results, and it's kind of fascinating to me. I used YOLO because when conducting this research, I studied some works of people, and they actually used some ResNets, yeah, like faster CNNs and stuff, but they also used YOLO, like older versions, and YOLO always was producing better results. And also YOLO is pretty performant, it's pretty damn fast. So when, for example, utilizing YOLO, we can like produce some actual use cases for like these networks. For example, we can just have a YOLO model, like put it on a drone and just fly drone over our over our rivers and over our shores, and it just can collect pretty valuable data. For example, we can detect big amounts of some like plastic garbage in rivers, and we can like send some people to like clean it up. And talking about YOLO, of course, in YOLO, it's pretty standard. We have a backbone, we have a detection head, we have the like you only look once approach that we like divide our image in a grid, and it produces some bounding boxes, some anchors, some class probabilities, and like picks the best one with the most confidence. Also, one of the like main advantages of YOLO is that it's makes this hard task of producing a bounding box. Actually, it just simplifies it to a regression task in the way the loss function is built. So like the main advantages of YOLO is obviously speed. It's pretty accurate. It's pretty simple to use. As many like good like PyTorch integration, you can actually pretty much like easily implement it in PyTorch, like, and it's flexible. And also about some evaluation metrics I used in this research, it was like pretty standard stuff like precision, recall F1, and of course our favorite mean average precision, like everyone uses it. And about and here you can see also some hyperparameters for like 3 main models. I call them the main because they produced the best results. Actually, I tweaked the parameters more and I produced more models, but they weren't really interesting like the same. First model was like just simple not pre-trained YOLO V8N model. It's like smaller version. with less amount of parameters. And I used Atom Optimizator like for everything because it's actually in general produces the best results. I use some momentum of 0.9 and learning rate of 0.001. And I trained it for like 100 epochs, and I actually saw some results. And results were like not the best precision, but it was actually pretty okay for all of the cases. Like it was around 0.4. And for plastic bottle, actually, we can see the results are pretty good. Like its precision is around 0.7 and MAP is around 0.7 as well, which are like results people were getting in their works before. And after that, I tried to like utilize this fine-tuning stuff and also increase some image size because my image dataset had images like with pretty big resolution, like the images are like 1,000 by 1,000 pixels, and I try to actually utilize some sort of this spatial information and increase the size to 800 and train this stuff like for 500 epochs. It's like took good 20 hours on my computer. My computer was like, the temperature was like about 90 degrees all the time. I was so afraid that my computer is gonna burn, but somehow we get through that. And this model actually produced, of course, the best results. I really liked it. Its precision was like, for all of the cases, is about 0.8, because also this, thanks to, in process of training, also your OV8 like produces this data augmentation stuff, and also it's like getting more and more actual data. And like for a plastic bottle, it's like it's around 0.85 85 like precision. It's pretty good. And the last result, I really wanted like to kill my graphic card, I guess, and I tried the big image size and bigger pre-trained YOLO-V8 model, YOLO-V8M. It has like 3 times the parameter amounts, like comparing to previous one, and I increased size to 2008, and only for 10 epochs, because one epoch was like taking like 2 something hours. And this model actually produced some pretty cool results, like precision is around 0.6, MIP is around 0.5 for all of the cases. Plastic bottle, of course, like the best of them all, because if we go back to like our distribution of annotations in our dataset, we can see that like plastic bottle like dominates very much. People really like expose them plastic bottles away just in a way, I guess. And yeah, and this model is actually pretty cool as well. I really like the third model, but to actually fully train it for around like, I guess, at least 100 epochs, I should have some more computational power. And here's actually some results of, not very pleasant to see, but we can see that images were not like seen by a network during training or validation processes, totally new like test case. And we can see that actually our model, like that's results of the best model, performs really well. It can detect really a lot of this, mostly plastic bottles, of course, but it's actually really hard to find some plastic bags like floating on the river. And the third like image is actually a screenshot from a video, because model like performs really well. It can actually produce on 60 FPS video, like produce predictions. That's pretty much all. Thank you for your attention. Thank you for the opportunity. If you have some questions, I will be glad to answer them.
Thank you so much, Andy, for the presentation. And I have seen there's a question in the chat. Tetiana Neskorodeva asks, well, just a second, I need to go back to chat. I just missed. Why were these parameters, hyperparameters, chosen for testing the 3 modes presented in the work? Why were these hyperparameters chosen?
I guess it's a question about why the hyperparameters were chosen for the models, not the modes. I suppose that's a typo.
Okay, maybe, probably.
Okay, actually, I like cross-validate on more amount of parameters, like much more. I like picked and choose like about 20, 30 variations, but those that are presented right here, they're just like that perform the best.
By perform the best, what do you mean perform the best?
Perform the best, they had the best like precision recall of one MAP metrics. They produced on validation data set.
Best precision. Okay, thank you.
Thank you.
Maybe Tetiana, maybe more questions? If
No, thank
no
you.
more questions. Thanks a lot. Thanks a lot for the question. Colleagues, again, you can use chat or raise your hand. I will give you the turn to ask the question. If not, then thanks a lot, Andrei, for the presentation. Thanks for saving the day. You allowed the next presenter to prepare. Thanks a lot.
Yes, thank you very much. Thank you for the opportunity.
Thank you for the presentation. So maybe Artem or Dmitry Stepanchikov, so will you be able, is it okay for you to present now?
Yes, okay.
Yeah, very good. No. I'm so glad. Can start share. Oh yes, you have already started. Yeah, we see the full screen.
No.
Well, maybe not the full screen. Let me. Yeah. Okay. Now I see the full screen. Okay. Yes.
Hi, my name is Artem Sharko. I'm presented our work monitoring state of plane bearings based on exponential determination models. Plane bearings are used on very low and medium speed diesel engine turbines and shaft lines. Monitoring technical, conditional, and diagnostic emergency defect is the basis for ensuring high reliability of equipment elements. Method of vibration signal processing is frequency and time frequency dominate are used to assess the technical condition of sliding bearing. Organization of monitoring observation of the operating equipment, conditional as means of equipment is reliability and fail safety. In this work method of analyzing vibration signals using the exponential diagnostic model were applied to monitoring the condition of ship sliding bearings. The use of the models allow the degradation trend to be observed in real time through data collection, post-processing, runs, and fetching of important function with fitting of predict curves. Methodology. Yes. Maintenance base of interactive conditional monitoring, fault detection, and resource forecast of power equipment requests as full set of information, characteristic, implement time, frequency, implement. The method of principal components allow reduce the dimension without significant loss of input information. Modeling of the distribute of the exponential diagnostic performance using the logarithmical subharmonical function. The function for the density of the logarithmical normal distribution a random vibration has the form. Degradation models extrapolate past behavior to predict future behavior. This type of calculation is approaching when determining the steady state, useful life, and complex equipment. The diagnostic profile of the test completion is the use statistically calculate the remaining time until the diagnostic indication reaches a Cartesian degradation level agreed with the equivalence. Statistical characteristics vibration signals in time frequency domain were determined during post-processing. In the time domain, 11 statistical characteristics was determined. Means, skewness, kurtosis, peak-to-peak, RMAs, grace factor, chap fraction, impulse fraction, magnetic fraction, energy. In frequency domain, 4 statistical characteristics were determined. Spectrum mean, SKM mean, spectral standard deviation, SKSTD, spectral asymmetry, and spectral axis. All of the above statistical characteristics of vibration signal can serve as potential indication of being conditional degradation. The main critical of belonging of the extracate statistical characteristic of vibration signals in frequency and time domain to the future analysis in the numerical values monitoring. For question statement of a belonging of statistical characteristic, the future analysis is processing the use formula. Future with the monitoring score grade is 0.3, selection to be combined as subsequent analysis to use the principal component method. In other, reduce the dimensionality of the analysis quantities and component future of vibration signals. The PCA principal component analysis method was implemented this work. Use the component material system MATLAB. The first principal component was calculated when processing the statistical characteristic of vibration signal with monitoring rate that 0.3. Its distribution depending on the day of measurement, which correction with the successful approach of the state of the plane bearing of failure. The first principal component in grade is the bearing approaches failure. This is the first principal component is promoting composition indication of beginning condition. Data collection in the first 20 days are considering tracing data. In this slide, we use the exponential degradation models, algorithmical implement in the MATLAB. Complete mathematical system to model the exponential degradation process and establish the remain useful life. Of bearing the degradation models is made by prediction with the monitoring signals crossing predetermined various values. The selection of the threshold value of the conditional indication can be based on chronological records of the bearing conditional or some subjects known values. Since is the chronological data in the study set the last value of the suitability indication is selection the threshold value. The selection of the threshold value is based on smoothed chronological data. The exponential diagnostical models also provide functionality to assess the signification of the slope. As on a significant slope of the performance indication detected, the models with forged the previous observation and restarted the estimate based on the initial priority values. The boundary of the fideliation intervals should be the dotted line in the figure. Cross the solution already on the 14th day of operation of the bearing. Therefore, it can be stated that after 40 days of operation, future operation of the bearing is unsafe. Conclusion. Improves the prediction accuracy requires constant repayment of the current information is produced step established by corresponding probability. The development and predictive models of characteristic and technical conditional based on the vibration parameters is a major step in the transforming the new form material repair necessary and usual equipment safety. Thank you for your attention.
Thank you so much, Artem, for the presentation. And now we have some colleagues who would like maybe ask some questions. Oh, there was a presenter from the different section who was going to ask questions. Now I see probably he went for his own section. Okay, sorry. Maybe there are some questions for Artem about the presentation, about the work done, about the future research, maybe. Well, Artem, as no questions, again, those who would like to reach you, they will ask us in the chat or write to the organizing committee, and then we pass the question to you. Thanks for the presentation. The next presenter is to be Georgy Yaskov, Andriy Chuhai, Yelizaveta Yaskova, Andriy Zhuravka. Do we have any of them? Not yet. Natalia Kusud, Vlada Svirsh, and Bogdan Potuzhny. Yes, I mean, no. Then Sergei Khlamov, Vadim Savanemich, Vladimir Vlasenko, Emil. Those people I'm trying to reach and find. They are from the section that starts, part of the section. Our workshop starts at 3 p.m. So it's probably they did not know. They can start. That they can be asked for being presenters so early. That is why probably I can't make you sitting here just waiting for the participants. Maybe as a suggestion, I will stay here and wait for the for the participants, and when they come here, they will give the presentations. As for you, I suggest maybe visit the other presentation, the other section, and then from time to time give a look at our section, at our workshop. Maybe the presentation already started. Just a second, maybe I have an update in the chat. Just a second. No. Okay, no future no fresher updates. So for now, thanks for those of you who joined us. We will start officially the next session at the next part of this workshop at 3 p.m. And those who maybe if someone else will join us, then we will continue. But I suggest you visiting other sections and then come back here. Maybe someone will present and you will be able to participate. Because we went such in a hurry, much earlier than the timetable. So thanks for being with us. Again, I'm back. I'm staying here for those who will join us, and do suggest to visiting other sections. For now, a short break until someone appears, or 3 p.m. Well, all the other participants will join us for the next part of the workshop. If any questions, feel free to write in the chat or talk. Now I'm muting myself, but I'll be here. You'll be seeing me if you need some. It's already 3 p.m. and I'm not sure. So you can hear me, right? I'm just.
Yes, yes.
Oh, thanks a lot. I'm confused. I'm confused. Yeah, we are.
So can I start?
Yes, please. Sri, please, the paper you're presenting, it's the third part, where it's getting online, the third part of the machine learning workshop within the Collins conference. Just a second. Allow me to adjust my. Oh yeah, I did. And the first presenter is going to give a speech on automated data mining on the single objects from the blurred astronomical CCD frames using the Lucy-Richardson deconvolution. Please, Sri, take the floor.
Yes, thank you. Good afternoon, dear participants of the conference. Today, authors present the paper called Automated Data Mining of the Single Objects from Blurred Astronomical CCD Frames using the Lucy-Richardson deconvolution. Now, the fast technological progress provokes creation of a big amount of data. There are a lot of different fields of science that use the high-dimensional data sets for analysis. One of them is astronomy. So in what ways the big data sets can be fed? This data can be fed in different forms, for example, file stream, video stream, physical data saved on the different service, virtual observatories, or even astroplates as we have in Mayaki in Odessa, main astronomical observatory. All this data can be received from the networks of automated ground or space-based observation systems, or even from the old astronomical archives. When we have a lot of astronomical data, what can we do with it? There are a lot of directions of research in astronomy. Some of them are solar system objects research, variable stars, asteroids, comets, near-Earth objects, satellites, and others. The regular series of frames can contain hundreds of frames, where in one frame a lot of thousands of objects are presented. There are a lot of challenges for the image formation posed by atmospheric turbulence, mechanical vibrations, and other distortions. Also, there are a lot of different types of telescopes aberrations that can cause the corrupted astronomical data. For example, diffraction rays, motion blur, vignetting, flare light, coma, and others. The data with some aberration is unnecessary information. Almost all aberrations can be removed by the different filters during the preprocessing stage. But what can we do with the blurring? Examples of blurry images of objects in digital frames are shown in this slide. The main reason of such blurring are the atmospheric disturbance, loss of diurnal tracking, inaccuracies in satellite tracking, or even wind gusts. So I want to tell you about developed cloud-based information system for astronomical image processing, which allows the end user to perform the blurred image restoration. For such image restoration, we selected the classical Lucy-Richardson deconvolution algorithm. This is an iterative technique designed for the restoration of images that had been blurred by a known point spread function, PSF. The essence of the Lucy-Richardson algorithm lies in its iterative approach to estimate the original image by minimizing the differences between the observed image and image convolved with the PSF. The developed web-based application was implemented in scope of the collection light technology, Kaleitec project, as independent system. Few words about the Kaleitec project and its main product Lemur software. On this slide, you can see the very brief sequence of the online processing images as saved from the telescope, then processed by Lemur or Kaleitec software in different modes, and we get the necessary results as light curves and appropriate reports about satellites, asteroids, comets, or other solar system objects. The Lemur software implements all data mining steps during processing the different types of astronomical information, which is fed online in automated mode. On this slide, you can see the results of frame processing by the Lemur software. There are raw frames on the left side and processed frames with alignment and centered view on the right side. Also, detected moving objects are presented on the right side. There are different technologies and tools were used during the development of such system. The main information is presented in this slide. Programming language is Python, Docker for the containerization, React as a front-end, Redis server, AWS platform for deployment and database maintenance, and Redis for task queue management. On this slide, you can see an architecture of the developed image deconvolution software. The designed architecture is suitable for vertical and horizontal scaling, and vertical scaling based on AWS EC2 service is used in current stage of research and development. On the next few slides, you will see some screenshots of user interface of the developed cloud-based application. Image processing in the system is represented by tasks. Each user can create an image processing task by selecting a specific method, setting parameters, and uploading an image. The application provides a comprehensive list of created image processing tasks, enabling users to manage and monitor their progress. For each task, detailed progress information is available, including stages from initiation to completion, enhancing transparency and user engagement. Once the image has been processed, user can view details regarding the execution time and the parameters utilized if the provided algorithm supports it. Additionally, processed result download is available in achieved format. The input and output frames comparison is presented in next two slides. As you can see on the left side, we had previously blurred images. On the right side, we have a certain point objects. Also, we performed the scalability tests. The results are in this slide. As you can see, for 6 workers on AWS, the total processing time was reduced at 55%. Testing was carried out on machine with 6 cores. Compared to existing analogs in the field of astronomical image processing, the developed application provides a number of advantages, like scalability potential, vertical and horizontal, low entry barrier, support for various image formats, including astronomical feeds format, as well as regular JPEG, and ease of the new image processing methods integration, and integration possibilities for the third-party services via REST API. The Kaleitech project is developed by enthusiasts. Kaleitech has assisted in making over 1,700 discoveries of asteroids, including 5 near-Earth objects, 21 true asteroids of Jupiter, 1 Centaur. It has been used in about 800,000 observations, during which 5 comets were discovered. Thank you for your attention.
Thank you for your presentation, Serhiy. I get the question, the recent solar eclipse, is there any information you might get from these images? Will you ever use it? Or it's for this task is of no use?
It's not for this task.
It's not for this task.
Yeah.
Okay.
The main purpose is just to detect objects.
Detect objects. So, well, this the object which was eclipsed, probably all have detected it. So there was no more need. No, there was no need in additional software. Okay, thanks a lot, Serhiy. I'm sorry for interrupting and jumping before someone else's questions. But please, colleagues, feel free to ask Serhiy question. Either raise your hand or just unmute yourself, or maybe just write in the chat and I will read it. And we can discuss them. I believe, Serhiy, no questions for now, but maybe someone else will come up with a question, and then I will transfer this question for you if it will be, let's say, in a chat or something. Thanks a lot again for the presentation. Thank you so much.
Thank you.
Thanks. Now I'm reaching for the second presentation. Serhiy Semerikov, Andriy Kupin, Dmitro Zubov, Maxim Kozay. I think I saw Maxim somewhere. I do see you. Twice. Is it okay that I see you twice?
It's okay. I connect from PC at my phone.
Okay, 2 devices. Okay.
2 devices.
So please take the floor. You can start your presentation.
Now Now I'm sharing my screen.
Yeah, we can see the full screen.
Okay, models and technologies for autoscaling based on machine learning for microservices architecture. Web services are used to invite a range of applications, including e-commerce system, banks, mobile operators, and web stores. For example, e-commerce system often use web services to process payments, deliver goods, and provide customer support. Banks use web services to provide financial services such as banking, loans, and deposits. Mobile operators use web services to manage their networks and provide services for their customers. And web stores use web services to catalog products, process orders, and deliver goods. The significance of web services is growing every year, so it has become crucial to ensure the scalability of web services. That is, the ability of the system to increase the processing amount with the increase in the number of users. The application of artificial intelligence to optimize the scaling of web services is an active area of research. Scientists and engineers are developing new AI methods and algorithms. They can help improve the efficiency and accuracy of the automated scaling in microservice architecture. Microservice architecture offers numerous advantages in terms of flexibility, scalability, and service independence, but it also introduces complexities associated with managing this distributed system. Utilizing design patterns in microservice architecture becomes exceedingly important as they offer a ready-made and proven solution to such challenges. Patterns helps find optimal ways to manage data consistency, implement service-to-service relationships, monitoring and scaling. They contribute to the creation of stable, efficient microservices applications, allowing developers to focus on application functionality rather than solving complex technical tasks. In microservice architecture, some design patterns have become extremely popular and widely adopted, such as SEGA segregated access of global atomicity, CQRS, command query responsibility, segregation, IP gateway, and circuit breaker. In a microservice architecture where system components are divided into separate services, situation may arise where one service successfully makes changes to the database while another services, depending on the changes, has not yet updated its data. This can lead to inconsistent data state in the system. Additionally, problems may arise during the execution of distributed transactions. To address issues with distributed transaction, the SEGA design pattern is used. This pattern is based on the idea of break down the large transaction to the small sub-transaction, which are executed separately in each microservice. If one of the sub-transaction fails, a compensating transaction is applied to undo or adjust the changes made by the preceding transactions. Complex query contain a large numbers of table connections and can block tables, preventing any write or update operation until the query is complete, and the database unblocks the tables. Database read operations are usually performed several times more frequently than write operation. And in a system with intensive transaction execution, the problems can be exacerbated. The CQRS. What? The CQRS pattern divides one object into two objects. So instead of execution both commands and queries for one object, we split this object into two objects, one for the commands and one for the query. A command is an operation that changes the state of an object, and the query does not change the state of the system. It just returns the result. For example, the database can be divided into two logical representations, one for commands and the other for queries. When using two physical databases in CQRS, a replica is created for the primary database. Microservices can communicate directly with each other without the need for centralized manager. However, as the microservice architecture system evolves and becomes more mature, and the number of microservices gradually increase, direct communication between microservices can lead to significant overheads, especially for calls that require multiple round trips between the API consumer and the API provider. A more efficient approach to addressing these issues is to use the API gateway pattern. Here all microservices communicate with each other, receive API calls from consumers, and then transform the received data into the data structure and protocols that API provider can understand and process. Using the API gateway significantly reduce direct one-to-one communication between services. Additionally, microservices are relieved from the code required to perform tasks such as API contract mapping, service discovery, and tasks related to controlling and providing access to system resources, authentication, authorization, accounting. The circuit breaker pattern is a design pattern used in microservice architecture to prevent system from making calls to a service that's likely to fail. It acts like an electrical circuit breaker, automatically detecting failures and preventing the application from attempting operations that are likely to fail. This pattern helps to maintain system stability and resilience for preventing cascading failures in distributed systems. The Saga CQRS API gateway and circuit breakers pattern helps address typical challenges in developing and managing microservices application, ensuring improved performance, reliability, and ease of maintenance. Microservice architecture systems are inherently complex due to numerous dependencies and relation in their operations. Therefore, models of artificial intelligence, machine learning, and deep learning can detect these dependencies and make predictions. A popular model of the artificial intelligence include neural networks, convolutional networks, regression models such as linear regression, polynomial regression, logistic regression, and multi-class classification models such as k-nearest algorithm, support vector machine algorithm, naive Bayes classifier algorithm, decision tree. Recurrent neural networks such as nonlinear non-parametric autoregressive model with exogenous inputs, long short-term memory, and gate recurrent unit type of neural network. Having analyzed the core concept and approach used in microservice architecture and machine learning, the next step is to synthesize approaches for integrating machine learning into microservice architecture system. The space for integrated machine learning into microservice architecture system is quite extensive and can be utilized for many different scenarios, but four main integration areas can be highlighted. System loading forecasting model, system protection model, system productivity degradation prediction model, and system resource planning model. With the help of
we were just lost.
using various features such as critical microservices response time and used to detect patterns in the operation of the microservice architecture system. Similar to the circuit breakers, this model can promptly determine whether a microservice is under heavy loads and address this issue before it becomes critical and starts negatively impacting other microservices. Так. Минуточку. System protection model. The third area of machine learning application is system security. In the era of the cyber security, it is important to have the ability to protect your microservice architecture system from targeted attacks. By studying the behavior of your microservice architecture system, the model can predict and detect attacks that may threaten the security of the system. And the last is the system resource and planning model. The fourth area of machine learning application is the system resource planning. As the system grows and evolves, it is important to properly allocate resource and adapt to the system needs. With machine learning, it is possible to learn which services require more resources and how much resources are needed for effective system scalability. So the integration of machine learning with a microservice architecture improves system efficiency, decision-making, and real-time adaptivity. The finding provides a foundation for future developments in intelligent system scaling. Thank you for attention. Does anybody have a question? I'm ready to answer.
Okay, thank you, Maxim, for the presentation. Yes, please, colleagues, step forward and ask the question. Either write it in chat or raise your hand or unmute yourself. So we could have a discussion. Maxim, I see no questions for now. If they will appear, we will be informed on our, let's say, email of the conference organizers email and let you know, and maybe there will be cooperation and discussion with those who ask the questions. Thank you for now for the presentation.
Okay.
Thank you so much. And I'm getting to the next presenter, Alexey Horokhvatsky. I saw your name. Yeah, Alexey, I see you. Will you be the presenter?
Victoria will be presenter.
Okay, Victoria.
Hello, I'm here.
Hello, Victoria. Yes, I can find you. You are feel free to share the screen.
Just a moment, please.
Okay, take your time.
Sorry. Hello, everyone. I would like to present.
We just maybe hear some noises, Victoria, but
Sorry. I'm not here. Hear you.
we can see the second probably slide.
You cannot see the second slide?
Yeah, we can see the second slide. Is it okay that we see it now?
Yes, is it okay? I can start at the beginning.
Okay. So we're supposed to hear something.
Sorry.
Just so we could, I just don't get it.
I don't understand some technical problems. What else?
Okay, maybe, okay. Let's not, it's difficult for me to understand what you might want to just present it, no? In your own words. Maybe, okay, maybe Victoria, take your time. take care of your issues. Maybe I will go to the next presenter because something doesn't. Yeah, I see the Vyacheslav Kovtun in here, and then we go back to your presentation. Meanwhile, you will have some time to take care of those issues. Okay.
Unfortunately, I need to go, and I cannot present my presentation later, and that's why I don't know.
Okay. Let's work on your presentation. I'll then present it now. Okay. We won't. Yeah.
I don't understand. You cannot hear or you cannot see my slides or someone else.
I can see the second slide. Maybe my colleague sees something else, and then I can hear you, and then you stop saying anything, and I can hear nothing, and but I can hear you when we're discussing.
You cannot hear me.
Now I can hear you.
Okay, just a moment. I show another variant of presentation. Maybe it will be better.
Okay, definitely.
Just a moment, please.
Yeah. For now, I do understand. We shall go back to Victoria in no time. I see Vyacheslav Kovtun. Okay, you will be the presenter after the Victoria or Oksana. It depends who will be in charge of presentation. Then Bogdan Melnik, Sergei Sveleba, Ivan Katarinchuk.
I'm sorry, so I will present now or not?
No.
I don't understand.
I'm just checking, are all my presenters in
Okay,
here?
okay, understand. I'm ready and I'm here. Thank you.
Thanks a lot. Very good. So I see Ivan Katarinchuk. You probably will be the next presenter. Okay, I can.
Okay.
Okay, I can find you're all here, and then will be probably after Ivan there will be Yuri Opotyak, the last presenter, because the speech we had on Tetiana Neskorodieva, we already had it, and Tetiana is here with us. So if any questions to Tetiana, then she probably will be able to answer all those questions, although she already presented the paper. Those of you who would like to.
I'm ready and I can try to show my presentation.
We would really love to. Yes, Victoria, please.
Tell me, please,
we can see it in
good variant of presentation or not. I don't know.
That's the first page. It's in PDF and then it's moving.
So I would like to tell you about semantic-based clustering for education, science, business interaction, bibliometric analysis. Despite the numerous studies, only a few have been published on the conceptual provision of education, science, business interaction analysis in an innovation economy. To remedy this shortcoming, it is advisable to analyze the structure of publications on the topic using bibliometric analysis. The relevance of bibliometric software is due to the fact that the modern wave of computer and information progress is transforming society and shaping the internet generation, which make it possible to highlight the possibility of solving any issues. Bibliometric technologies allow categorizing and analyzing large amount of historical data obtained as a result of research conducted over the certain period in order to information from the repository. Bibliometric analysis rely on quantitative methods and therefore can avoid of mitigate bias. Unlike systematic literature review, which usually rely on qualitative methods, which can be obtained by interruption bias from researchers with different academic backgrounds. The contribution of the paper includes the application of non-NLP and email methods, including semantic clustering of keywords and clustering quality evaluation for the extension of bibliometric visualization. There are several main softwares that are predominantly used for analyzing bibliometric analysis, each with its own strengths and weaknesses. The sample of data for the study was formed from different databases: Web of Science, Elsevier Scopus, Dimension, and etc. Each of them has unique properties and functions. Web of Science and Scopus are currently the most widely used international networks and integrated database that allows scholars to study and evaluate publications, patterns, reviews, and other analytic documents. There is a comparison of bibliometric software for education, science, business interaction analysis in innovation economy. Thus, table shows the bibliometric provides numerous tools that allow researchers to perform in-depth bibliometric analysis. One of these tools is the website application, Biblioshani. Biblioshani allow users without programming skills to perform bibliometric analysis using graphical interfaces. The selected publications are analyzed by year of publication, country, title, publisher, open access level, funding agency, etc. It is advisable to analyze the thematic and citation statistic to conduct the comprehensive analysis in literature sources, according to the scientometric database Scopus, as it can provide a significant number of documents and offer more citation-rich data. The full set of publication data was loaded from the Scopus database according to the previous stages of study. This table shows the main bibliometric data generated by bibliometric software Biblioshani. And in this table, you can see the main bibliometric data which was generated by Biblioshani. Biblioshani make it easy to see the data flow by creating synchrony diagram. The first figure shows the report chart or synchrony chart by countries, keywords, and terms of title of publication to reflect the proportions of research area on education, science, and business interaction in innovation economy for each country and the dynamics of publication. And you can see some trends of it. Sorry, just a moment. The second picture show factorial map. To interpret the results of factorial map, the relative position and distribution of points allow the measures of measures is used. The closer the words show in figure, the most comparable the distribution is. The terms allocated closer to the center of the map are more common of the study and have received more attention during the analyzing period. And the terms that are more distributed are associated with less discussed research subjects. In order to deepen the quantitative characteristic of bibliometric analysis and interrupt it with qualitative conclusion, it is advisable to conduct the cluster analysis with the possibility of forming certain groups according to the subject of the research and focusing the attention of scientists on certain aspects of education, science, business interaction in innovation economy. More detailed semantic analysis and visualization of the key area of this topic you can see on the using the WOS viewer tools and building visualization map based on the result of search queries, which we obtained in the previous slide. Despite charts from different bibliometric software, Upright and Handley, most of them still can show only the entire picture without significant details for the topic being investigated and flexible tuning of the parameters being used to create charts. The usage of some explicit natural language processing and machine learning methods, NLP, could be applied in order to get more flexible results from required details level. The traditional NLP text processing routine include such aspects as text cleaning and removing unaccessible symbols, split of text to token, stemming or lemmatization, and processing of embedding according to the problem. There are a lot of clustering methods, and we choose one of the simplest chi-means that requires the effective quantity of clusters to be known beforehand. The results you can see on these pictures and table. Previous figure show clustering results and allow us to build some clusters. Some clusters. The content of the clusters is similar in terms of keywords and proves certain connection, the subtopic of research within the topic. A list of clustering keywords for different embedding model are presented in this table. On the last slide, you can see some results and some conclusions which we obtain from this research. Thank you very much for your attention, and if you have some questions, we will try to answer them.
Thank you, Victoria. I'm so glad everything is okay with the presentation. So please, colleagues, ask your questions, if any. Maybe I should start. Victoria, can you move back to this, probably the first image with such a net? It's so nice. I wanted to ask something about it.
Unfortunately, I hear you very bad, very quiet, and I don't understand.
Is it better? Is it better now? Is it any better
yeah.
now? Okay, okay. Can you move, please, to this to the probably the slide with first figure? Yeah, this one. No, that was the figure. Yes, in here. Can you please comment on the top figure? I see on the left, it's the column is called DE, and the biggest red rectangle is next to innovation, that it moves to somehow USA, and then there is TITM. What are those? Can you please explain?
Yes, we just a moment. I find our results. We'll find. Yeah, on the first figure, this sync chart. Yeah.
Okay.
This Sync chart shows the report chart by countries, keywords, and title of publication. The first table is country, the second keywords, and the third is the title of publication. And as you can see from this figure, there is a concentration of publication of our topic is in such countries as USA, United Kingdom, Germany, Italy, Spain, and Ukraine. We have 9 items. It is essential to add that these countries from the vast majority of international authorships. What I can say.
No, understand the keywords and countries and the most often used keywords goes to the innovation is the most often keyword, and then the USA produces the most number of the papers you were interested in. Well, I get the main idea. Thanks. Well, I get it. Thanks a lot.
Sorry, the first is keywords and then country.
Yeah. Well, we understood. Yeah,
make a mistake.
We understood that. Well, at least I understood. Thanks a lot. Well, maybe more questions for Victoria. Okay, if no questions, then thanks a lot, Victoria. I'm so glad we overcome these issues and you were able to present your presentation. Very interesting. Thank you so much, Victoria. Thank you so much.
Thank you too.
Thank you. And we've already known that Vyacheslav Kovtun, am I right, will be the next presenter? Oh, yes, I can see almost. Let me take care of my, yeah, we can see the presentation.
Dear colleagues, let me present to your attention the results of the research named The Concept of Efficient Utilization of the Uplink Frequency Resource of a Smart Factory 5G Cluster by IoT Devices. Speaker is Vyacheslav Kovtun. The implementation of Industry 4.0 in organizing smart manufacturing significantly complicates the design stage. The most flexible and parametrically responsive to the challenges of Industry 4.0 is the 5G platform, the permissible frequency spectrum for the application of which is strictly regulated, finite, and overloaded. Attention should be paid to the issue of horizontal control. The latter involves reasonable QoS policy-based organization of alternative service periods for different types of traffic based on their source, which the allocated frequency range. This research proposes an original analytically substantiated response to this relevant scientific and applied issue. Among the plethora of network technologies, the one most closely aligned with the aforementioned concept of horizontal control is licensed shared access control technology. In examination of the literature, reviewed a substantial number of papers dedicated to the simulating this technology. However, no analytical models was put forth in those works either. The analytical aspect of this issue has been inadequately explored, and to derive the model solution, cognitive radio technology was employed. This technology facilitated dynamic spectrum access. Nevertheless, the models analyzed under non-stationary conditions did not incorporate the influence of the periods during which the frequency band operates or remain inactive over time. Here we can see the object of the research, which is the functioning process of a 5G smart factory cluster, the monopolistic use of the uplink frequency resource of which is claimed by both human operators and IoT devices. The subject of the research comprises elements of probability theory, Markov chains theory, and functional analysis. The aim of the research is to analytically justify the concept of efficient utilization of the uplink frequency resource of a smart factory 5G cluster by IoT devices. The focus of our research is a smart factory 5G cluster, which a coverage zone limited by the cycle, which a corresponding diameter, centered at the location of the base station. Let's assume that within the velocity of the 5G cluster, IoT devices are formally distributed, which attempt to transfer information messages to the base station, which corresponding intensivity. The duration of transmission is information messages by your device is a stochastic parameter exponentially distributed, which the corresponding intensivity. We assume that the quality characteristic of the communication channel between the IoT device and the base station are mostly determined by the distance between those entities. Here we can see that the uplink traffic speed for any end device in the investigated 5G cluster is a function of its type and its distance from the base station, which is represented by the expression 1. According to QoS, if the uplink connection speed that the base station can offer to response of an incoming request from IoT device is lower than the guaranteed speed, then the base station switch to autonomous mode regarding to new uplink requests, during which all incoming requests from end devices directed to it are lost. The utilization of the state of uplink frequency resource of the 5G cluster at the time t, characterized by the function epsilon. The introduced stochastic parameters are sufficient to describe the operating process of the uplink frequency resource of the 5G cluster directly in the term of the state space, that which is represented on the slide. Here we represent the parameter Q, which characterizes the probability that the input request from n+1 end device will be accepted, given that the base station is already servicing information traffic from n end devices. The specificity of the evaluation of the stochastic process Y allows us to classify it into the class of Markov processes. This enables us to move from the conditional probabilities 2 and 3 to stationary probabilities Q. Here we can represent the computationally efficient information technology for their calculation. For the instance of the process Y, we characterize its evolution in the metric of indicators such as the probability of implementing the uplink autonomous mode, the probability of interruption of IoT device servicing due to the activation of the uplink autonomous mode, and the average number of devices being servicing in the system due to the uplink autonomous mode. Those metrics are represented by the expression 5, 6, and 7, respectively. We applied the capabilities of simulation modeling to evaluate the ordinary instance of a smart factory 5G cluster for the monopolistic use of the uplink frequency resource, within is sought after by both human operators and IoT devices. The evaluation of the functioning process of the investigated instance carried out by the quality metric 6 and 7. To demonstrate the informativeness of the proposed metric, the calculation were made and the results are presented on Fig 1 and Fig 2 respectively. From the graphs shown on Fig 1, it can be observed that the quality indicator 6 is highly sensitive, as evidenced by the small increments in the ordinal scale. Additionally, it is evident that the power allocated to support information traffic in the frequency band omega increases, the interruption of servicing EO device probability value sharply decreases due to the activation of the uplink autonomous mode. The results presented in the figure 2 are intriguing. We will discuss this question a little bit later. So now let's move to the figure 3 and figure 4. From the Fig 3, it can be observed that the probability of interruption of servicing an EO device due to the activation of the uplink autonomous mode begins to increase exponentially, which the corresponding R value. This phenomenon is practically independent of the parameter tau, but it is instead fully determined by the power value. This conclusion is supported by the graph presented on the figure 4. Finally, let's move to the results presented on the figure 5 and figure 6. Based on the information presented in figures 5 and 6, we observe trends that are characteristic of figures 1 to 4. So now is the time for conclusion. The article investigates the functioning process of a smart factory 5G cluster, where both human operators and industrial Internet of Things devices contend of monopolistic use of uplink frequency resource based on the defined quality of service policy. To analytically formalize this process, the authors have developed a Markov model. This model reflects both the inherent characteristics of the studied process and the mechanism of adaptive power control, which considers the type of traffic being serviced by the base station at any given moment of time. Within the framework of the created model, a qualitative metric is proposed, capable to characterizing the evaluation of the studied process. Instance, through a set of indicators such as the probability of realizing uplink autonomous mode, the probability of interruption of EO device servicing due to the activation of the uplink autonomous mode, and the average number of devices being serviced in the smart factory 5G cluster during the implementation of the uplink autonomous mode. Thank you for attention, dear colleagues, and I will be glad to answer your questions.
Thank you for presentation. And yes, colleagues, the question for our presenter, Vasyl, maybe chat or just raise your hand or unmute yourself. As for now, Vasyl, see no questions. Maybe they will arise a little bit later. And thanks for the presentation. Thank you so much. Thanks for the presentation. The next topic is about the multi-layer neural network training error. And the presenter, Ivan Katarynchuk, am I right? Are you here with us? Yes, probably you are. Will you be there?
Yes, yes. Do you see my screen?
Yes, we do.
Okay. Dear colleagues, I am pleased to present the results of your works for you. The works was performed at the Ivan Franko National University of Lviv. My name is Ivan Katarynchuk. I am Associate Professor of Optoelectronics and Information Technologies Department. The multi-layer neural network used for the recognition of printed digit numbers. The conducted studies of the learning error when using the optimization learning methods Adam Max and Grad proves that these methods do not affect the value of the optimal learning speed, and it does not depend on the change of the optimization parameter beta 2. For all considered optimization method, optimal learning speed is 0.45. We deal with four-dimension array. We use 3 and 5 and 4 and 7 arrays. The sample will consist of 5 options for presenting the number without distortion and with distortion. If array consists 1 or 0 distortion, we call it homogeneous, otherwise not homogeneous or heterogeneous. We use the mapping function to analyze the error functions. Figures on this slide shows the Fourier spectra at the learning speed that corresponds to the retraining of the neural network when alpha equals 0.8 and the branching diagram for n equal 100 iteration. According to the figure, the Fourier spectrum is characterized by a wide range of existing harmonics. According to the branching diagram, starting with the learning speed of alpha bigger than 0.45, the process of the appearance of local minima should be followed. That is, the Fourier future increase of the learning speed begins to the described by the process of doubling of the number of local minima in the learning error function. This one. In the final case, this leads to the appearance of chaotic behavior of learning error function. This part of this figure. Consider it in combination with Fourier spectra and the branching diagram. The conclusion is suggested that the increase of the number of harmonic on the Fourier spectra and the number of branches on the branching diagrams is associated with the appearance of local minima in the behavior of the target error functions. And the appearance of local minima is due to the retraining of neurons. The determination of the value of the learning speed with the process of the appearance of local minima due to the learning process of neuron take place. This mechanism assumes the absence of the local minima and follows the retraining regime. The algorithm for solving this problem consists in determining the optimal value of the learning speed and therefore the optimal value of the learning error at with the first harmonic occurs of the learning error function. Under this condition, the obtained optimal value of the learning speed alpha is equal to 0.45. This slide shows the two curves, the quality of training and testing represented in this slide. I show good results of the training. So the change of the beta 2 parameters for a homogeneous or non-homogeneous input array do not affect the training results when using the Adam optimization method. Beta 2 is represent the exponential decay rate for the second moment estimates in Adam method. Increasing the dimension of the array from 3 and 5 to 4 and 7 comes to decrease in the learning error, not only for the homogeneous array, but also for the non-homogeneous arrays. The Adam Max optimization method is an improvement version of the Adam optimization algorithm. Adam Max uses the maximum value of the absolute value of the gradient for each parameter instead of using the average of the squares of the gradient. This allows us to focus on the large gradients, which can improve the stability of the model. The Fourier spectra and branches diagram for Adam Max show same results, as for Adam optimization method. Changes the value of the optimization parameter beta 2 affects the testing error, both for a homogeneous array and for not homogeneous array. Increasing the value of the beta 2 causes a decrease in the testing error by almost an order of magnitude at 100 iteration. Therefore, the learning quality curve is higher than the corresponding testing curve. By increasing the parameter beta 2 for a homogeneous array, the expansion of the iteration interval in this, there is sharp change in the steepness of this dependence can be traced. That is the large of the value of the beta 2 parameter, the greater the number of the iteration required to achieve a certain testing accuracy. For a non-homogeneous array, the quality of the training and testing when the parameter beta 2 improves. The interval of the sharp change in each iteration decreases at the beginning, but the increases again. Such a feature of behavior, both learning and testing errors from the number of the iteration and noted above attested to the important role of the large gradient, the improve the stability and learning speed of the neural network when using the optimization method ADAMAX compared to the Adam optimization method. The main idea of IMS graph is to fix the problem of increasing the value of second-order moments estimated in Adam. The Fourier spectra and branching diagrams for Adam's graph show the same results as for Adam optimization method. Changing the value of the optimization parameter beta 2 affects the testing error both for a homogeneous array and not homogeneous array. Increasing the value of beta 2 cases a decrease in the testing error by almost an order of magnitude for a homogeneous array and almost by order of magnitude for not homogeneous array at 100 iteration. The dependencies of the training quality represented by number 1 and testing quality representation number 2 red color shown on slide. The interval of a sharp change of the dependencies of the number of iteration depends on both the optimization parameter beta 2 and the homogeneous of the input array. For a non-homogeneous arrays as estimated above, the training error is smaller than the testing error. Satisfactory learning process with minimal learning error observed when the learning speed value equal to the optimum. The appearance of the first harmonic of Fourier spectra of the learning error function is correspondent to optimal learning speed. The optimization method of learning ADAMAX IMS graphs do not affect on the value of the optimal learning speed. The obtained Fourier spectra of the learning error function branching diagram and the special behavior of the error function when using optimization learning method proves that the main reason of the appearance of the local minimum of the error function is the relearning process. Dear colleagues, thank you for attention and please be free to ask any questions or.
Okay, thank you, Ivan, for the presentation. Yeah, we are cheering you up to ask questions. Maybe there is something you would like to ask our presenter. Were there anywhere any contacts on your slides, Ivan? Can you maybe move to the slide if they were.
Slide. Okay, maybe I write to the chat my contacts.
Okay.
One moment.
Yes, okay. It will be nice.
One moment.
Okay.
Yes, yes, of course.
Okay. So, so if any questions, there will be a contact in the chat. Ivan will send it. Either contact the conference organizers, we will be able to get you in contact with Ivan. And okay, yes, if there will be contacts, your probably email address in the chat. So those of you who have questions can then can ask your questions in a written way.
Of course.
Oh, Ivan, yeah, Ivan sent his email address. Thank you so much, Ivan, for the presentation.
Thank you.
Any kind of contact.
Thank you for the presentation.
We have everything to contact Ivan with the questions and maybe oral questions if anyone would like to.
Thanks.
Well, maybe no questions for now. Thank you, Ivan, for the presentation. Thank you so much. And it's
Sorry, we don't hear you. We don't.
Sorry. I just it accidentally. I didn't mean it. So as I said, Tetiana Neskorodeva already presented the presentation. We will have the video. If you need, you may contact us. I will grab it for you and send it. But maybe you have some questions about her presentation on intellectual classification method of gymnastic elements based on combinations of descriptive and generative approaches. I like the presentation so much, by the way. So again, any questions? Tetiana is in the chat. I will read it, and you can know everything you want from Tetiana about her presentation. And now probably maybe the last presentation by Yuri Opotyak, am I right? It's the talk on implementation of neural-like network diffusifier for mobile platform motion control systems. Oh, yes, we can. Yes, and there's an address in the chat for Tetiana, so any questions you can ask with the chat or directly with the email. Thank you so much, Tetiana. So, Yuri, take the floor.
Okay. I want to present our study implementation of neural-like network diffusifier for mobile platform motion control system. Today, classical methods of mobile platform controls in a stationary environment are known, which are based on the use of dynamic and kinematic characteristics of movements of mobile platform. However, such methods are ineffective when it is necessary to operate the mobile platform in uncertain condition using inaccurate or incomplete information about the external environment in which with unstructured and dynamic data. Fuzzy logic methods are used to control the movement of vehicles in such condition in which the state of external environment and values of vehicle movements parameters are described by fuzzy values. So, however, one of the main disadvantages of method of movement control of vehicles using fuzzy logic is the difficulty of choosing defuzzification algorithm. One of the ways to implement such tools is the use of neural or neural-like networks. The main components of a mobile platform control system using fuzzy logic are distance sensors, fuzzification unit, decision-making unit, the ruler base, and the defuzzification unit. The main stage of the formation of signals to control the movement of mobile platform using fuzzy logic are fuzzification, decision-making, and defuzzification. In the falsification state, the input data X coming from the navigation range sensor converted into input value is converted from input values to fuzzy values. Such information is carried out by comparing the specific value of input and the value of membership function of corresponding term in the input linguistic variables. To control the motion of mobile platform, a triangular shape of membership function is chosen, which is given the following equation on the slide. And graphic one of the advantages of triangular shape of membership function is it easy of implementation. A graphical representation of corresponding membership function of input linguistic variables and the output for implementation of different modes of movement are given on the figures. This at the decision-making stage are implemented a sufficient number of consistency of fuzzy rules, which should adequately reflect the purpose of the cover of possible cases of mobile platform movements. The decision-making blocks, the rules are written in the following form, and for example, at the decision-making stage, the input fuzzy set is converted to the output fuzzy set using a fuzzy rules based according to the following expression shown on slide. Now we go to the falsification stage. At the stage of defuzzification, the fuzzy initial value coming from decision-making unit is converted into precise output value supplied to the mobile platform engines. The defuzzification stage is the last step of process of fuzzy motion control of the mobile platform, which translate fuzzy inferences into concrete precision value or actions. On this stage, there are many methods of defuzzification, and the main of which are center of gravity, centroid, largest maximum, Heights ratio, weighted average, etc. For example, the center of gravity centroid method is one of the popular methods of defuzzification. This method is used to convert fuzzy output values into specific quantity value. The basic idea is to find the center of gravity of average values and of indeterminate mass represented fuzzy output values. However, main disadvantages of these defuzzification methods are that the type of parameters of the methods are chosen subjectively and may partially not correspond to reality, and the difficulty of adaptation of movement of mobile platform to the changes in the environment due to the static nature of chosen method. So we propose to implement defuzzification with the help of neural-like networks. The peculiarity of defuzzification with the use of neural-like network is replacement of stages of accumulation and defuzzification at the calculation of control signals way, which will reduce the computational complexity and increase the accuracy of obtaining control signal for mobile platform. To implement the defacsifier, we choose the neural-like network based on the model of sequential geometric transformation developed by one of the author, Roman Tkachenko. The structure of synthesized controller with neural-like defacsification is shown on slide, where FU is the falsification unit, FIGU is the fuzzy inference generation unit, and LDU is the neural-like defacsification unit. X is the input data from navigation sensor, and Y is the resulting value of control signal. We developed a fuzzy logic controller software with neural-like defacsification that provides the generation of mobile platform motion control signal, such as speed, angle of rotation, input navigation data, such as distance to obstacles, distance to target, speed, direction of movement to the target, is used to generate a signal for motion control of mobile platform. The implementation of fuzzy logic controller with neural-like defacsification requires the formation of matrix of training vectors. For example, the output variable sigma for the deviation of mobile platform relative to its direction has five terms that shown on slide. A view of membership function of source variables is shown on the slide on the left side, and the neural network architecture for sigma output is shown on the right side of this slide. To form the table of training vectors for output sigma, we use the membership function of this output variable. We will set the value of output variable y to sigma, and for each of them, find the corresponding value mf. Now, as a result of calculation, we obtained the value of training vectors that are given in table. The number of training vector for this case is 20, and number of neural-like networks is 5. Neural-like network inputs is 5. In the prediction phase, an input vector is supplied to neural-like network input, and the output of this network we receive the predicted value of control variable to control movement of mobile platform. We tested technical characteristics of developed software on the various hardware platforms. Testing was performed for variants with different numbers of neural-like network defacsification input. The network configuration and datasets used were the same in both cases, and the test results are presented in table. So we consider and test an approach to implement the defacsification unit using neural network. To develop the algorithm neural network based on the paradigm of model of successive geometric transformation and fuzzy logic were used. The technical characteristics of developed software based on various hardware platforms were evaluated. The implementation of defacsification operation was tested using hardware of personal computer in code blocks environment And at the Orange P0 microcomputer based on SOC H3 in the Linux OS environment. In both cases, the duration of neural network training operation is almost the same, and execution time of the specification for computer and microcomputer platform is about 20 milliseconds. Such values can be considered sufficient to implement control process in real time. So, thanks for your attention.
And thank you for the presentation, Yuri. Thank you so much. And yes, again, we're back to our audience. If there are any questions, please ask our presenter so we could discuss the results. Well, seems maybe no questions, Yuri, for now. Well, if there will be any question or asked the organizers, we will send those questions for you and you could discuss with colleagues something of an interest. Thank you so much, Yuri, for the presentation. And it's my pleasure to announce that these were all the presentations which are supposed to be presented in the machine learning workshop within the Collins 2024 conference. I do believe the conference was a success, as quite a lot of interesting speeches were presented and interesting presentations and discussions were made. And that would be for the machine learning workshop, the end. I'm really glad you have found the time and your dedication to the conference, and thanks for the presentation. But there will be a closure, well, the final the final meeting of the final session. It starts at 5:15, let's say in 55 minutes. But you will have to go to, you will have to use another link to join this final session. And it won't be long, up to 15 minutes. So those of you who would like, and I do invite all of you, please visit our final session. Maybe you would like to share your ideas and maybe some feedback. It would be very valuable for us as for the organizers of the conference to know how can we become better, well, good and better from your point of view. And we will definitely take it into consideration to be better the next year. And this year, thank you so much for this session. I will see those of you who, I hope I will see all of you at the final session at 5:15 after the break, and we might discuss some organizing issues there if you would like to share your feedback. Thank you so much for this workshop. See you at the final session.
Thank you.
Thank you. Goodbye.
Thank you. Goodbye.
Well, and see you 5:15 at the final session. Goodbye.
Of course.
Okay.
Okay, goodbye. See you.
Goodbye.
Goodbye. Thank you, Maxim. And now